We should be live, yes.
Okay.
As far as I know.
Okay, so then I will start. Sorry, all kinds of stuff going on.
Hello. Hey.
Hi.
Hello.
Hi, Veronica. Thank you for joining again. I was just mentioning to everybody that it's I'm going to do a slightly more formal introduction because it's graduate school open day. So, okay, guys. All right. To kick off today, I just want to welcome everybody to the second day of a two-part event as part of the Architectural Association's Design Research Labs Phase 2 thesis reviews. Over the 2 days, we've been discussing, and we will continue to discuss, new design research agenda that we are calling social ecologies. It's really building up, I think, on a history of explorations within the lab of computation and its role in deeper kind of social, political, and design ecologies that we're working on. Primarily, we've been investigating aspects of living, notions of working and culture, and how those things work within larger kind of territories of cultural infrastructures, urbanism, and design production systems. Particularly with this current year's batch of thesis projects, we've also been exploring more open frameworks in terms of creating kind of the more participatory and more co-authored kind of ways of thinking about how design systems can be worked on as projects that are much more shared and collective. The program in itself is a 16-month course. In method and in practice, we have a very self-organized notion of design in terms of teams coming together, international group of students who are working with staff in a very collaborative and horizontal framework on very open and quite complex problems. And I think in terms of the practice, we've tried to complement that by incorporating design tools and creating events such as this that kind of affords us the opportunity to have this as a much more open, transparent, and collective conversation. Over the 2 days, if the ones that have joined us yesterday, you'll see that some of the design thesis projects are broken down into 3 streams. One of them led by Patrick Schumacher and Pierre Andrea, who are working on subjects on the thematic of parametric semiology. They've been looking at aspects of co-authored urbanism, and they're using London as a case study scenario of an implementation strategy for large-scale densification of the urbanism and the urban fabric of London, prototyping a proposal that is looking at structural optimization and analytical software as a design tool to couple basically performance criteria with notions of sustainability and more ecological frameworks to consider, in particular looking at the landscape and the flooding issues relative to dealing with adjacent waterways. Sajay and Alicia have been working on a design thesis agenda, which is really looking at gamification as a kind of strategy to think about a more participatory way of co-designing urbanism. They're looking in terms of different ways of dealing with gameplay as a strategy to develop a kind of an intelligence in terms of the kinds of discussions and conversations that lead to informed decision-making. So beyond the planning tool, it is basically working with a thesis that's trying to open up the process of how the built environment comes into form and to look at decision-making as a very active agent in terms of the different players and how they are synthesized within an open platform framework. In my studio, my name is Theodore Sparopoulos. I direct the program. I run a studio with Mustafa El Said and Apostolis Despotidis. We've been looking at notions of self-organization and what we've been looking at under the thematic of disaster complexity, and trying to see if there are models that are more kind of real-time and behavioral that can be applied to some of the crisis and issues that are very prevalent today. The models of the systems that we've been looking at are more logistical models that you can find in sea, land, and airport systems in terms of high choreography of elements that are in constant dialogue, real-time communication. We've been looking at the Amazon warehouse and auto store as kind of also models of a kind of robotic and let's call it semi-autonomous way of negotiating space. So looking at it as a kind of architecture / infrastructure that can augment the existing urban environments. We will be looking at 2 of those projects today. With that, I think it goes without saying that we're always quite privileged to have a community of people who join us for these events, to be able to discuss the work and to shed some experience and feedback for us to critically kind of evaluate and to think in terms of how the projects are being developed, some of the frameworks, some of the tools that we're looking at, and also to put attention maybe to certain things that we don't necessarily foreground. And I have to say that this jury in particular, under very difficult circumstances for everyone, we feel quite privileged to have such a distinguished group. Over the 2 days, we will be joined by an amazing group of people that we would like to call friends, colleagues, and kind of partners in some of these larger kind of problems. We've launched a small microsite which has been shared, and I think Pier Andrea will put it in this chat, but also on the YouTube chat for everybody to see in detail the backgrounds of our guests. I won't go into everybody's bios, but they're amazingly distinguished, from lead strategic project directors at Google to architects and researchers in all kinds of institutions, from academic to professional practice. And we feel very fortunate that everybody is joining us to have these conversations. This is a real-time event, so it's being streamed for people to be able to participate in a way, and to share that also under the terms that we find ourselves not in the lecture hall of the Architectural Association, which obviously we cherish, but in an unapologetic way. I think that this online and remote version of the jury has given us an opportunity really to include a large cohort of people into the conversations, and I think it's probably something that is more meaningful under all of the duress that it is to have a discussion about architecture in a more expanded form. So with that, the schedule for today is 3 projects. In the first session, we will take a break for an hour and we will conclude with 3 projects. There will be 1 from each studio. And with that, I just want to thank everybody for joining us and ask the first team to basically launch their presentation. Thanks very much.
Okay, hello, we are Industrialized. My name is Mauricio, and with me is Dilara and Akash. How we go, could you go to the next one, Dilara, please? How we go from places to places tell us a much larger story about cities, and the economic prosperity of cities depends on moving people efficiently, inclusively, and sustainably. Transport reflects countless choices made over time by residents, business, policymakers, and governments. Sadly, a legacy of designing our cities around cars has left many streets unattractive places to walk, cycle, or use public transportation. The cities developed after 20th century, which shape our metropolitan of today, are lacking to satisfy the varied demands on its citizens. Therefore, we propose a pedestrianized, car-free, and dense urbanism that allows social interactions and experience richness, enabling a participatory mechanism through the self-governance of the built environment.
In order to meet a satisfying urbanism, generative, democratic, and participatory contribution systems today allow citizens to join together, decide and design under certain rules as to enhance these aspects. In an ideal world, development teams will take a very slow process in order to achieve the best options along with difficulties to meet both providers and clients' desires. Participatory urbanism allows this process to be much more democratic by allowing the users into the development process. And with the adaptation of decentralized manufacturing with Industry 4.0, costs and weights become much more manageable and easy to imply. Along with reduces cost and harm to environment, democratic urbanism and planning platforms allows much more desired environments by its users due to commonly taken decisions and less tests to be run physically and cyber-physically. Seeing the potential of cyber-physical systems, we aim to achieve a workable, participatory, and diverse urbanism supplied by industrial construction techniques.
We aim to have architectural geometries that are fabrication and structural performance aware. The architecture that was pedestrian friendly and very effective use of material is now possible with 3D printing. Brick architecture is labor consumed and labor intense. However, we're bringing back the qualities that was like a consequence of masonry architecture. We want to use 3D printing to address architecture that corresponds to a pedestrian's nice city, with a level of detail that helps people to navigate and to articulate the space. We see a huge potential in true freeform 3D printing in applications that require mass customization and on-demand fabrication shown by architects such as Antonio Gaudí and Pierre Nervi. The insight in that principles, could you go to the next one? The insight in these principles of unreinforced masonry can aid in understanding what can be printed and what cannot be printed. So we develop some connections pieces in order, go to the next one, please. So we develop some connections pieces in order to enrich the computational geometry with as many physical constraints as possible in order to develop a system that allows to work with the geometry and operation directly. Also, we did a columns with differentiation corrugations with spiral pipes that allows us to connect more directions for a hybrid design. A fractal differentiation in width of the columns has been taken on multiple levels. Next one. We are interested in how we embed a kit of parts in a system based on the use of choice that can adapt multiple variations on the same stack. Next one. So each voxel has an awareness of an agency of where it is located within the aggregation. A kit of parts are designed in a way that can be easily interchangeable and swappable. A variation of cross-sectional shapes generate cost-efficient and ease the construction process.
Yeah, the structure is divided into pieces for ease of construction, and due to the limitation of the manufacturing sizes, we are dividing it into wall bricks, slab bricks, and the roof bricks, which can be customized as per the user's need and can be stacked each over other. Next one, please. The construction sequence we use is a multi-material system where it starts with a single 3D printed part of column, which can be connected with similar 3D printed parts by means of metal plates. The slab structure is supported by flat and bent wooden beams that can be notched into the corrugations positioned in the 3D printed column. The roof part is 3D printed as well, where the part gets divided where the angle of the print exceeds 45 degrees. Next one.
In order to construct cities that have a dynamic relationship with the people who live there, we propose a bottom-up approach to link city and its citizens with the metaverse by giving citizens the tools and parameters. We've developed a fast, de-risk, and cost-efficient process for the design and delivery of urban development. Our contribution platform is driven by multiple levels of contributions. Selections of each mode users will be used to collect data inputs for parameters that are necessary to achieve a workable urbanism, along with investors who are providers of the development under examination and filter of architects and experts. The generation will be run on Euston, which is currently undergoing a regeneration and is the heart of London, which makes it very suitable for a test to reach city's demands. Along with its busy location, it holds a high potential of population growth, which requires intense urbanization for future. To start off with, citizens are asked to rate basic programs to give platform information about what crowd wants. Crowd intelligence supplies AI-driven urban generation of ours. 3 major seats selected by citizens are being located according to context of the area. The magnitude of the seeds affect to its area is graded by the majority of votes. Through inputs of citizens given to AI, a vote magnitude-based magnetic field algorithm is run on the area. The divisions of blocks are made by connecting existing paths to newly generated ones. As citizens vote, the template of the city changes according to votes results. Each of them form other possibilities for the area and are being shown to the contributors. For the use of magnetic fields, we look up to then and today's walkable cities, block areas, and we were informed that an average of 2,500 square meters block areas were mostly common on these cities. This was used as another parameter for our urban generation. In order to divide the blocks in most efficient way, we use the space syntax-based approach for diversification of streets in the neighborhood and put the limit of 3 to 8 meters width since we don't need any curb size for cars. As users join the platform, they initially supply the urban generation shown previously. Users will be defining their demands, choosing their preferences for their desired space, customize and explore what is currently being developed cyber-physically, along with investors who are supplying the economics of the built-to-be spaces. Contribution is defined by 3 levels. Citizens who are seeking ownership to receive a better space, visitors who will be experiencing the outcome and joining decision-making, and investors who will fund and potentially gain by the end of contribution if contribution becomes successful for all. Here, contributions will also convert money into tokens, which are defined by currency of the value of the area in real time and changed by demands. Citizens will start off with declaring their space of interest and budget. All users will select a pre-made city template to begin with, which are made by their previous contribution. Users will be enabled to see features of each selection and amount of contributors in. Each of them will act as servers. To proceed, citizens are asked to claim their priority outcomes from the site, such as approximate proximity to parks, accessibility, and etc. Data within the template and suitable blocks will be shown to be selected by the citizens for configuration. Users are able to examine traits of the blocks that are suitable for their demands. Here they can see demand-driven valuation of the lot and other traits as well. When they decide on a lot, users will be taken into a multiplayer configuration for selected block. According to plot traits, a selection of massing that respects the urban plan and other constraints the plot has will be shown. And as they select, they will be able to see the numbers of citizens through the massing selection. Massings will come with predefined cores, and as a result of selections, they will assign geometry to the voxels. The most played out massing, Once the units are owned, users will be asked to connect with their adjacent blocks on certain levels, or they will be notified if their neighbor already declared for a connection beforehand. Negotiation will show how the user's selected voxel story is being affected. Citizens will be informed for the possible results of connection that is being offered. If citizens confirm a beneficial connection, their plot gets valued, so they will earn since development will serve better to the neighborhood. And at the end, out of selection of geometries, they will assign a geometry to their spaces. The most played out massing will be the most efficient geometry, and it will be considered on urban model to be auctioned for further development.
different voxel configuration were used to spatially define different typologies of units, which the player can choose within the citizen part of the game to fill in the predefined massing of a given plot. The structural geometry that fills these voxels are made of a series of arches supported by columns together, creating a vault-like structure. Next slide, please. As the gameplay allows the players to place different voxel configuration next to each other and also change the orientation of these voxel configuration, geometric studies were carried out to find how these structures can merge and adapt to different conditions of adjacency and also for different wall directions to form a continuous printable form. This slide here shows a prototypical process starting from the plot to arrange the voxels and defining the geometrical equivalent of the voxel configuration, taking into consideration the adjacency of the wall to orientation for accessibility. Yeah, next slide, please. Structural optimization was used to find the column dimensions for a given load condition, finding the right balance to achieve maximum structural strength with minimum material usage, resulting in a gradual hierarchy of column sizes as we move from bottom to top. Yeah, next slide.
The viewers' contribution will not contain any economy. They will only be there to give comments and declare their thoughts around the cyber-physical development to give a better idea to contributors who are in charge. And the contribution of investors start with asking investors' interest and budgets converted into game tokens and select servers. They will be able to see traits of each building, the demand, and the value. Investors will be there to contribute and fund to the development to be built by only covering construction price. As they select demanded developments, they will be gaining tokens also by the increase of value. So the ones that are not funded will be forced to be replayed until it's built. And at the end, users will be enabled to test and experience the development in multiple occasions and conditions.
Yeah, this is one of the iteration of our gameplay with which we were able to achieve social interactive ecologies that can host diverse intensities of spaces in it. Next one.
Also, we are trying to adopt the efficiency of industrialization in more democratic and customizable approach. Next one, please. So we propose a pop-up factory in order to reduce the time labor. The printer is shipped to the actual plot and to automate the entire process from pre-print, printing, and post-printing.
And these are the interface of the games that can be played on. Thank you.
Thank you.
Thanks, guys. I think if you can leave your trailer on just so that people can see an overview of the project, we can kick off the conversation.
I can start maybe.
Yeah, please.
Thank you very much for the presentation. Really nice to see the connection between, let's say, the fabrication opportunities of the Industry 4.0 with the kind of participatory urbanism ideas that you have. I find it super interesting. And maybe I was all along hoping to see a little bit more the relationship between, let's say, the printing direction or the printing process, the printing expertise in relation to the construction, to the kind of geometric outcome of it. As in, but now when I see your renders, it looks as if everything was printed in one direction. And I was wondering if you have done studies where your geometrical variation and the different opportunities that you have, and what is their impact when it comes to production, and also in relation to the performance, the structure, the introduction of installation systems, etc. So I am missing a little bit of detailing, if I may say, when it comes to the production opportunities. Do you, maybe well, it's just to say, because I think you have a very, very good overall idea, I think. Very, very well communicated, large views on what could result from it, and also very beautifully detailed idea about how you would bring production on site. But I am missing a little bit the relationship between, let's say, construction performance and fabrication expertise. Maybe you have it, but you have missed to explain it or something.
According to the 3D printing in different directions, we take in consideration like references like Antonio Gaudí and how he assembled in pieces these kind of columns. And we try to replicate and imitate. That was our main inspiration. If we go to the slide, maybe like 14 or 7, we can show like how the 3D printing like was like trying to tilt or like change the variation like as branching, as you can see in some of the towers that we can have here. That was the main reference and the main goal, that ones. And also in slide 9, I guess. I don't know if that like.
Yeah, it's exactly. I was hoping that these modules would actually increase in detail, and that then you would have a follow up on this. Did you actually have the possibility to prototype some of these at full scale?
Yeah, we missed that opportunity, unfortunately.
Yes. But well, the main idea was to do, as you said, like to start like tilting or changing the direction of the 3D printing, because otherwise it's going to be like a normal 3D printer like a machine, and that's not the idea. Since we have like the robots, we need to squeeze that opportunity with that we have here, and that was the main goal actually with the tectonics.
Just to speak on behalf of that, I mean, the students they did start with a series of studies, but when we had lockdown and all of that, that obviously was not really on the table for them to work. So I think primarily what they tried to do is to survey really what other research labs have been achieving and try to kind of embed that knowledge more directly into the way that they've been thinking, at least about the kind of component aspects of it. So the scalability issues and maybe some of those things, I think you guys should feel quite open to have those conversations, have some very expert critics in it, and to just talk a little bit about some of those decisions. It's not about right and wrong. It's really about trying to understand how you're trying to optimize a production process and how that impacts the way that you're thinking about that. I think what's important most is to try to see how there is always a negotiation between decision making. And I think part of today's opportunity is for you guys to share that and to discuss that with your critics and to see what their advice would be as you guys are considering. Sorry.
If I can pick up more on that point, I think I totally agree with the comment from Martha, right? I think because you're using 3D printing, right? And I totally understand what you're saying, Theo, about the situation to test, you know, but I would have also wanted to see what the option of 3D printing will start giving you as a new way of creating these structures, right? Because in a way, and I think it's all very nice, it's very interesting, very well done, documented, and also I like the expression of that you can read that it's 3D printed. But the part that I don't like is that it still just looks like a way to do a new 3D printing exoskeletons, right? I think, and especially on the shell conditions, you don't read that these are done by 3D printing, right? You read that these are just almost cladding with 3D printing elements and just putting them on top of either a concrete or a steel structure, right? So I think that further analysis will have made you reinvent typologies of structure and of space. I know it's very ambitious and I know it's difficult, but I think to open up that chapter of what this new era of construction could become, I think that's maybe going more futuristic into what the technology is giving us. So for example, here you start just seeing a bit of these sort of strange shell conditions that might not be easy to do it with 3D printing, right? Because there is no analysis of the structure, right? I think that would be my main sort of, let's say in a way it's commendable, the work that we're seeing, but I would have liked to see much more further development on that. Just to touch quickly on the master plan, I think that just becomes the organization, not on the final renderings, but on the initial analysis. It becomes too conventional and not taking more parameters like distance between buildings, right? Shading, views. I think it becomes too rigid, too conventional, which is also goes against your sort of reinventing construction and fabrication processes and stays too short on the master plan. Yeah. But I think overall it's quite well put together. So congratulations on that. Yeah.
To build on Marta and Paolo's comments as well, really excellent presentation and a fantastic proposition. On the matter of using 3D printing for the fabrication, you touched upon creating a pop-up factory. Can you hear me okay?
Yeah.
Sort of a pop-up factory. I'd be really interested when you're fabricating without the limitations of a gantry and you have that freedom, it's really interesting to look at your fabrication units as a dynamic part of the overall system, which sort of are part of the evolution of the landscape. And thinking about it, not just at the setup, but how they could add on to the buildings ongoing, how they could be part of the decision making and how they could be part of the how the landscape as it's evolving is being experienced physically, how people want to adapt it and the inhabitants. And so that the fabricator elements of 3D printers become a dynamic and mobile unit of the actual urban landscape that can keep on evolving it. That's sort of the beauty of not having the restriction limits of the gantry. And even you see them as a swarm. Some of the research I did back at MIT, we looked at little weavers that all worked as a swarm and had communication between them. And the other element that was really interesting when you talk about a car-free environment and the distinction between citizens and visitors. It's really interesting to then see how the decisions that are being made and the choices of the participants in the game relate to the concept of commuting and to how communities get structured. It's interesting how urbanization really has always been required high density because we want human endeavor to come together and have that physical interaction, but whether that is necessarily a necessity yet still, and how this could create.
I think we lost a little bit your final sentence.
Yes, we lost it at the end.
Apologies. My connection is a little bit fickle today. Yes, basically, in summary, the point was about the idea of a car-free and workable environment. It's interesting to just see how the choices that are being made relate to the commuting distributions of people visiting and how does that form the communities, whether it's a more distributed and localized communities. It's interesting just to explore those dynamics and how those could evolve.
Just want to make a few comments as well. So overall impression is very intricate, beautiful, a nice urban fabric with a nice set variety and public spaces and in between spaces. I think that the kind of vaulted condition, it looks a little bit funny, not quite architectural, is difficult to understand. You have a number of types there which you haven't explained. They're not all, and rotating. I mean, it doesn't connect up with the urbanism. So that's, one doesn't know how you arrived at this scheme, which seems to be quite different from the urbanism. And we don't know about the various programmatic types or morphological types, how they tie in with programmatic types. So there's a lack of explanation, but I think it's beautifully crafted and designed, and one can see how you work with these modular systems. You can get this intricacy and level of detail across variety. And I do like, it seems you're working with 3D concrete printing of skeletons. It might be that you're working with metal printed, these kind of panel and glass frame insets, or is it ceramic? So I like that there's materiality differentiation. And then you have these kind of forms which are opening up, the forms where they make more space on the ground. But we don't know what it is. I think that speaks to, I can guess maybe what these various versions are, but you haven't explained much. And again, it's very different from the urban block pattern you showed us, and we don't know how the game arrives at that. And also when it comes to the game, I think the point wasn't it that you invite audiences into a virtual version of that. So it's unclear where this is. How you make your choices into a context which already has a number of shops and places and co-residents, and how you then interact. You only show a kind of neutral block grid, and then placing some so it's not interactive. Then somebody is placing some of these voxels, and it basically nearly only into the context of the original master plan. The master plan also, what you haven't addressed is, obviously that doesn't have only cubicle, because it has radial city conditions. It has these kind of wedge form blocks. I think that makes sense. That's where I think when you work with 3D printing, you can morph and adapt your modules and details, and you're not restricted truly to a rigid, mass-produced module, but to kind of an adaptive parametric module. So the number of, let's say, maybe it was a matter of time, but there's more in the project than comes through. And on an aesthetic level, as I said, I do find these now in the foreground, these kind of shell configurations not very refined aesthetically, and maybe they look over-structured. Everything is on that very narrow module of structure. Maybe it's a little bit constraining and wouldn't apply to some of the more larger social space you might need in a fabric like this. But overall, I mean, it's very convincing. Thanks.
Thank you.
Thank you.
Yeah, I think just to pick up on Martha's and Patrick's points, and also Nasia and Paulo, I think what we found, like with this one project, is that that you make perhaps not as convincingly as it could have been, but at least you do make a case for use of 3D printing in a sense counter to where it is currently used, or the suggested use for 3D printing is for mass production of like hundreds and hundreds of thousands of houses. And it is more for leveraging the capacity of 3D printing, the speed of construction, and less for the tectonic and the articulatory and the expressive capacities, and how that can actually bring back a level of detail in architecture that is perhaps necessary when you consider pedestrianized urbanism, right? That like the more people are close to buildings, they want to see more texture, and like it's not a barren mass-produced architecture. There is so you try to make the case for that, which I think we found one of the stronger points of your project was that you're making that counterpoint to where 3D printing is currently suggested as a solution, and where you did so you suggest that possibility, and like where you perhaps fell a bit short is like in the items already mentioned, to explore the kind of tectonic correlation between various masonry conditions or masonry techniques, and correlating that with, like, programmatic or user experiential spaces and or qualities. So overall, like, you made a very convincing case that this is indeed a viable project, and so congratulations on that. And so we feel enthused enough that, like, we might there might be a version 2 of your project, right? That but you have left enough on the table, unfortunately, for there is for other teams to pick up as well. So maybe it's both good and bad, and so there's lots of convincing elements, but there's also some elements that leave something to be desired.
I mean, if I can contribute maybe something, I think one of the things that I've appreciated about your project, which maybe is not coming through in the way that you've chosen to do a series of iterations in terms of thinking about how one could apply the strategy. I mean, this is probably like iteration 3 or 4 of your urbanism, and in terms of the topology of the kinds of buildings. And I think maybe one of the things for the studio and for yourselves to consider the difference between presenting a piece of design research and to try to somehow clarify maybe some of the decision-making strategies that you've had in terms of the building types. Because I remember early on in the conversation, the urbanisms were more matte buildings, and we were talking about the issues about the scale of continuity between buildings, to really think about the urban fabric as in a topology that is actually maybe more close to some of the ways that block development is in London. And I think one of those aspects that this urbanism that is somehow being presented, it seems more like it's a pilot project, like it's a proof of concept of testing certain kinds of buildings, but not really going into the operational aspects of urbanism and how that is more kind of deeply seated as a design project. So it reads more prototypical, and I think the value of your research is more in its prototypical deployment, meaning like how do you correlate a sensibility of a kind of digital twin, and how does that somehow impact? Because I think the complexity of the project, at least from my side, was always that tension between how do we think about the production of architecture, the differences between what we would do on site, what we would do off site, and how would that be opened up in a more participatory way to kind of engage in those problems. And I think in some ways, that tension between production and participation is not coming through, but I think is really, for me, where I think the studio's long, let's call it thesis arc, is kind of very important. What I like about your project, which is basically what people are really commenting on, is that fabrication and production has a critical role in that. I think the conversation begins and ends at printing right now, because you're not talking so much about the design strategies that would bring on the table, where the site is also a real-time kind of construction site, and how does that sort of work over time? And I think the conversations that we've had through the project, I think, have been very meaningful. So I just want to kind of put that on the table, because I think that's where we start to really problematize, I think, some of these aspects. I'm happy to see that you guys ran the system fully to be able to evaluate, but when you see the densification of your urbanism to the adjacent area, the question of these kind of isolated buildings, I think, return to some of the earlier kind of intuitions of maybe making some of these larger kind of interconnected buildings than these kind of isolated kind of buildings that are nested together but not physically connected. So I think that these are strategies that you guys could redeploy because you have worked in a systemic way. But I think in terms of presenting the work, I think it's very important to share, I think, some of the design iterations so that the conversation in terms of how you make informed decisions happen. And it's not necessarily right or wrong, but that tension, I think, is something that doesn't come across today as much from the design research part, because I think you guys elected to keep the presentation very visually tight, and I think it's quite professional. But I also think like architecture is a messy business. And especially when we're speaking about how we can somehow open up that discussion with all of these different elements, really co-designing and being constraints in terms of how we think about things. I think it's a good project to build on. So I agree with Sajay. It's a project that puts a lot of things on the table. But I would like to actually, hear you guys discuss and engage the critics a little bit more, if I'm honest, like the decisions of production, like the decisions of site, and even the decisions of the kind of buildings that you guys are proposing. Because once again, I think the building footprints are quite small. They seem like some of these testing scenarios of, experimental housing, for example, that was done in Berlin and so forth, which are really like pilots, like really testing scenarios like San Jose does, let's say, in terms of prototyping possible real world kind of deployments. So I think for the studio, I think it's good to situate that. And I think because sidewalk labs and all of these kind of alternative models were also directly in conversation, I think it's a good suggestion from my side anyway to use the same oversight that you had in evaluating their work analytically and see how you would address your project on those terms as you're putting together your thesis book. So just for the critics and for those who are watching, the students continue for 2 weeks to really put together their final thesis document. And I think how you foreground that and how you communicate that, I think is very important. So I would really try to bring in a lot of the design experiments, which, as I was mentioning to Martha, a lot of the physical experiments were impacted. But in terms of the digital and the simulation and the iterative ones, I think that's where you guys had focused a lot of your attention. It's important to really speak to some of those decisions, especially in terms of building types and how you guys thought about the walkability and so forth. Because if it's just about resolution in terms of more granular aspects, because I walk next to a building by itself, that's not exactly what the larger ambition is. But I think your network, your association, what you think the buildings are, how their life processes, I think it's important to speak to some of those issues. And
Theo, can I add something also?
Of course.
I think considering that they have 2 more weeks in relation to their thesis,
yes.
One aspect that I think is very, at least for me, very critical is that if you take into account the freedom that 3D printing gives you, and you start to create, and by the way, you allow people to participate in the design, if you want, of the massing and so on. I will connect to the comments that Patrick was making about all the other subsystems that will come in connection with your 3D printed structure, right? So it seems to me that there is a little bit of a, it's not, I don't want to say contradiction, but a little bit of tension, if you want, with deploying production on site for structural elements that are so varied that then require other elements, say glass, say fenestration, say handrails, say whatever, that then have a kind of range of variation that is incredible, but that they need to be centrally produced somewhere else and then brought on site. So there is something there that somehow creates a little bit of a shortcut in my head. Yes. And what I would like is that maybe in the coming 2 weeks, you could take one of these cases and investigate, what kind of variations of windows can be produced through your game. And could you have some of these let's say, standardized and let the 3D printing assume the variations between those standardized windows. And that's what you play with. You know what I mean? So that the windows could be deployed on site with the same ease than the 3D printing of components as well. You know, so there is something there that somehow doesn't match when everything has the same architectural freedom, the same, let's say, status, when in fact you are only producing one system.
Yeah, I think that's a really important point, Marta. I also think that they can critically, address the issue of modularity, as Patrick was bringing onto the table. Now, when I say to assess that, is that they took decisions, and in some of the earlier examples, there was much more free-form printing. There were thoughts about optimization, and I guess my suggestion to the students is also for the conversations and for the other teams presenting, it is important sometimes to really speak to the various kind of studies and the design research that leads to this. Because in some sense, this is a snapshot of one of those catalogs, which they chose to run with. And I think that that's the difference between presenting it as a piece of design research that has multiple test case scenarios and as basically a proposal. And I think that there are a lot of tensions, and I think we have a lot of work to be done. But I think in terms of the conversation and the feedback that you guys are giving, I think it's spot on. And I think things that we should, and we've had conversations, and I think it's an important part for the students to also hear it from you guys.
I just want to add one more thing in terms of the urbanism. How you need to make that more coherent. I'm not sure. At the moment, there's just a jarring, nearly contradiction between the block models you show and then the final. And to show how the game actually could be played, there's not much game playing. So at the moment, if you look at honestly, at the current scheme, you have, it's more these individual buildings. There's a lot of open space, which we don't know how the game is generating that, and how this is valued and decided upon. And you have, in a way, you have something which the outcome is relatively, I don't know if it's what the game, let's say, tit for tat or a sequential agglomeration would deliver, because you have these groups, typology groups, 3 or 4 I can identify, monotypology groups. That's really what you would predict. Would you want to have like to like? And one doesn't know, is that a precondition, of the master plan? Probably not. It's difficult. Of course, it's difficult to simulate a game, and maybe you have to play it. It's not thematized enough. So I think a little bit more work on maybe also inverse engineering of the game with respect to the outcome of the urbanism, which leads to an outcome. And you somehow arrived intuitively at an outcome which you thought was pleasant, and the block models wouldn't have been satisfying, because there's no public space, there's very narrow streets and so on. So maybe you have to re-engineer the game to arrive at your outcome.
Yeah,
I think just to add one last thing, I think I totally agree with that sort of dislocation of the urban with the architectural expression. I think that's quite clear. I totally agree, Patrick. I just find that the other sort of discontinuity that I find is that I understand the voxelization of each plot and the modularity of it, but then what I think is a contradiction with the 3D printing is the repetition of it, right? When you're 3D printing, you don't need to always be printing the exact same piece, and then end up with a very monotonous outcome, right? I think modularity could be respected for issues of structure and just the expectation of modules, but there could be also subtle variation that show the potential of 3D printing, which can create uniqueness in the system and not like mass production, right?
I think one of the types is doing that. The one where the melting shells, they are obviously unique.
But then that melting is also very repetitive, right? So it doesn't, and the melting is, I think, the same, right? When we reach that level of 3D printing, you will want to have perfect geometrical outputs, right? And it does look a bit messy and just out of control, which would be the opposite of what you want with 3D printing.
And to just a very final comment to build on what Paolo and Marta said, I also think it's interesting to see in the conflicts of the panels and the structures is to also consider material interface and the potential for material gradients that opens up with 3D printing that could actually create an even higher level of variability in looking at the performance and functionality of materials with regards to the geometry.
Is there any comments from Yele or Veronica before we move on?
Yes. So what I did miss in the presentation, which is very holistic, which I appreciated, which is really cool, and also in a sense building on top of the last decade of intensive fabrication research, right? Is that there are so many techniques that look for a problem to solve, and here the problem it could potentially solved is further developed, and I find that very, very useful. But what I did miss in the presentation is sort of this is also this project is also continuation, right? Maybe a continuation of the work of Constant in New Babylon or the metabolists in Japan, and I. Let's say this presentation has been so focused on the proposition, and I know you have a slot of only 20 minutes, so maybe this is more for in the booklet, but sort of connecting to the culture of architecture from which this proposition follows from would be welcome in my view. The other thing is that I had a little bit of a challenge grasping the temporal dimension of the project, right? So as a user, I can state my preferences, but how does the project evolve over time, right? Is that this looks like not a residency where you spend the rest of your life, but maybe, right? It's kind of, it seems of a sort of transitionatory nature, this project, and that seems not to have been that much addressed, right? Also relating to the combinatoric nature of the elements. That's
just to add. I think a lot has already been said, and I really appreciate the presentation. But to add on these aspects of the digital twin, I think it would be really interesting to start to look at the gameplay and also the potential of the digital twin from a let's say life-centric perspective, so that how to turn the digital twin into a biodigital one, because what you're addressing is also placemaking and this kind of generation of a neighborhood that is pedestrian friendly, also through attention to space in between the buildings. So my question would be, who is or how is the programming of the public space going to take place? Because a lot of this placemaking and generation of a neighborhood really is about generation of rather good public space, and this functionality and shared space in between the buildings is often the key to a functioning neighborhood. So I would want to see more about the strategies for this kind of continuous urban landscape that make it a walkable and livable neighborhood. That is precisely as Jelle just said, it's not built all at once. So what happens in different phases of the development? Is the factory developing along the growth of the neighborhood? And also in this kind of temporal sense, what is the afterlife of these structures? As also we discussed a little bit yesterday, that what happens after, let's say, 10 years or 20 years, if the neighborhood needs to be reconfigured, how can this be done? And again, then you can return back to the digital twin, because that is your repository of earlier decisions and that can inform the future decisions. So it's also a lot about building that kind of architecture of the digital twin, the virtual a fellow of the physical reality. So yeah, I'm curious who is the moderator and facilitator in that case, and how can the system work in the long run. So thanks.
Yeah, I think those are two really good comments to bring this one to a close. And I think the aspects of time and duration and who is participating and
maybe
how
just a concluding something that they can do for the book, like I think what Veronica said and Yele said, kind of this idea that technologies normally look for problems to be solved, and like you have done enough to suggest that, like, you know, whether it's the technologies of metaverse and digital twins or technologies of 3D printing, these are worthy problems to be solved, you know, like the urbanism, pedestrian urbanism, and the corresponding architecture, and a kind of time-based temporal growing master model. So maybe you should articulate those, like to say, like, this is just version 1 of what can be achieved, a taste of what and perhaps articulate the outlook for where future work could enhance these research trajectories, as Theo mentioned.
Okay, thanks, guys. It's a good way to start the morning. Thank you. The afternoon. So.
Thank you.
Thank you.
Thanks, guys. Can we get the next team?
Hello everyone, we are Team Seismos from Spiropolis Studio. I'm Razvan, and here with me there is Aya and Cass, and we are going to present a post-disaster autonomous housing system. For decades, humanitarian architects have stressed continuously the importance of addressing post-disaster scenarios. However, often the responses were inappropriate shelters built only for a small proportion of the affected population. Architecture needs to move beyond its traditional role of designing inert buildings in places of relative certainty to becoming facilitators of building processes that involve people in places of uncertainty and rapid unexpected change. Among the different kinds of natural disasters affecting our life, the earthquake is by far the most unpredictable. Nowadays, the architectural responses to earthquakes and other critical situations are mainly based on military tents and other highly inefficient shelters that cannot surpass the magnitude of a natural disaster. In order to respond to the complex challenges of a disaster, we worked on designing an autonomous housing system, which is completely automatic, three-dimensional, rapid deployable, real-time, adaptive, and mobile. Real-time control systems like Kiva and AutoStore were deeply analyzed to systematically design a framework that is capable to efficiently respond to a post-disaster scenario. Earthquake-proof units are transforming, autonomously moving, and aggregating in order to form housing clusters that are adapting in real time to address people's needs. Cellular automata, pathfinding models, and other computational strategies were used to rationalize the system, which aims to be time, space, and energy efficient. Digital and physical prototypes were designed and made during the process, targeting to achieve a minimal and compact structure that is able to move, transform, and aggregate with a minimum usage of material and energy. The resulting housing clusters are together forming an autonomous, mobile, and adaptive organism that can shelter, heal, and frame a social ecology where architecture and humans are intertwined. Traditionally, goods are moved around a distribution center using a conveyor system or by human operating machines. In Kiva's approach, items are stored on portable storage units. When an order is entered into the Kiva database system, the software locates the closest robot to the item and directs it to retrieve it. The mobile robot navigates around the warehouse by following a series of barcode stickers on the floor. Each drive unit has a sensor that prevents it from colliding with others. When the drive unit reaches the target location, it slides underneath the pod and lifts it off the ground. The robot then carries the pod to the target. On the other hand, AutoStore optimizes storage density to its maximum capacity, allowing 4 times the inventory in the same space. Over time, the system automatically learns which products have a higher rotation, storing them on the top of the layer to ensure faster picking times. The main differences between the two systems are, in fact, AutoStore is a 3D system and Kiva is 2D. More than that, AutoStore uses vertical baskets to store objects, while Kiva uses shelves. After an online purchase was made, the order is received at the warehouse and the system locates the closest robot to the needed object. When found, the order is assigned and the robot travels autonomously to the shelf and lifts it. Driving towards the target, the robot avoids other robots on the shelf and finds the optimal path towards target. When reaching the target, it queues and waits for its turn and then leaves to accomplish another order. Similarly to Kiva, at AutoStore, the system locates a pod and assigns the task. After it lifts the pod, the robot dives to the targeted area and leaves the collected objects to the workstation and then returns to beam to another spot. Both systems are using grid informational systems and pathfinding algorithms in order to efficiently achieve tasks in real time in an autonomous manner. Because of their high anticipatory capabilities, Kiva and AutoStore stand as main models for our project. Grid-based informational system and pathfinding algorithms were merged to generate a system that can efficiently respond to the magnitude of a natural disaster and challenge the fixed and finite state of the present architectural approaches.
Our project is a post-disaster autonomous housing system, which is completely automatic, three-dimensional, rapid deployable, real-time, adaptive, and mobile. Our system is a part of the city, embedded and stored within the urban fabric in places that are considered to be safe when disaster occurred. The warehouse in which our units are being stored are systematically placed in locations that are close to the possible deploy site. Our project is stored within warehouses in a packed condition to maximum the space and the number of units that are to be deployed. When disaster occurs, our units activated by autonomously transform in order to descend and then leave the warehouse towards the nearest safe zone. The unit firstly mapped the surroundings with the aim to scan the entire complexity of a post-disaster urban context. Like in the SLAM project, our system generates a real-time map of the city from the warehouse to the targeted safe zone. We worked on a pathfinding algorithm that are optimally detect map and react to the confronted obstacles and find the shortest path from the warehouse to a targeted safe zone. Multiple interactions were made until reaching the optimal settings for the system to work efficiently in terms of obstacle proximity, process of searching, and shortest path generation. We also tested the algorithm in a scenario with multiple warehouses and multiple safe zones, ending up with an interlinked infrastructural system in which all the targets are connected to all the safe zones in case units switch sites or warehouses. The unit can also detect, avoid, or climb existing obstacles by forming an ant bridge. In order to cross from one side to the other, the collective behavior is used to both scan the environment and surpass any problem on the way by aggregation and mobility.
After scanning the post-disaster environment, the units shape a grid within the safe zones in a relationship to the nearby obstacles. If the state of the area is stable, multiple safe zones are generated within the same neighborhood. The units can adapt any typology of the surroundings, and when a larger mass of empty land is found, the system generates a large grid where units can collectively deploy and aggregate. Our system uses cellular automata neighbor-based growth rules to populate the chosen safe area. The cross-like family formations are using two types of units, a frame that represents a public unit and a cube that represents a living unit. The ratio between the two types of units changes according to the number of people our system needs to shelter. When reaching the boundary, our system grows upwards up to 3 floors producing a vertical shaft that can be used for vertical circulation and other services. The following floors are also constrained to the boundary previously generated on the ground. This is an example of a small population of 464 units that firstly set the boundary and then grow horizontally and vertically based on a 1:3 ratio between public and living units. Like in Kiva and AutoStore, each cell embeds information and it is able to self-organize as a collective based on neighbors and the 3D grid. Different densities and porosities occur when the system uses different public living ratios. On the same safe zone with an approximate area of 10,000 square meters, the units can form clusters that can be populated by 1,000 to 4,000 people. This simulation showcases a large population made based on cellular automata rules that can generate 7,650 living units that can accommodate up to 12,000 people. Paths are generated within the grid when occupying the site to efficiently distribute all the units in the fastest way to their position within the 3D matrix.
The units are taking in consideration both the obstacles on the chosen safe zone and the boundary generated in the beginning. A closest point is chosen in order to systematically deploy. Every unit comes to the safe zone with a group of 9 tiles that can form a phase. The first phase after deployment is the shed mode, in which the units for a short period of time form a space to gather the people. In the zone, if the zone is smaller than 4x4 units, the shed mode is single height. If the zone is bigger, the space will be double height. If there are small obstacles and the rough ground within the safe zone, the system will build on top of those and form a single height upper layer. If there are large obstacles like trees, the system purely avoids and aggregates around them. This animation showcases the life cycle of our system. Initially, the site is rapidly occupied by 2 layers of units. One cluster of units can be divided into several smaller parts, and in the same time, multiple clusters can be connected or physically separated. Once people don't need the units anymore, they'll go back to the warehouse and be recycled for future deployment. In the subdivision mode, multiple layers start to appear, forming structure up to 3 floors height. In the same time, internal partitions multiply and individual units emerge. Like in Kiva and AutoStore, all the units can change in real time their location within the matrix to adapt to the population growth or to any internal functional need. Horizontal and vertical circulation and arrangement in a large generative population model can be challenging. So the pathfinding algorithm is also used internally in our system as an interface between humans and architecture. The units are using the algorithm for both deploying and the reconfiguration within the aggregation, while the humans can follow traces to the desired location or to exit the structure when an emergency occurs. Like in Kiva, every cell and unit of our system knows its location within the matrix and is a part of an interface that can be used by humans to both communicate and circulate the space. The units illuminate, change their shape, color, position, and enclosure to react and adapt to humans' needs.
Our first idea for the prototype was to create a geometry that can both be rigid and mobile by shape-shifting from a cube-based form to a cylindrical form. The units can climb, move, and change direction on their self-built network. To achieve the transforming process, the green part should be inside the circle. It can be separated into 2 motions of 3-dimensional rotation. In the end, both point A and B should be inside the cylinder. So the whole process of this cube to cylinder transforming is like that. The units are using magnetic joints to climb on each other. And to also lock into semi-permanent or permanent position in order to form a rigid 3D structure. The expansion of the frame unit is made possible by extending 12 pairs of telescoping tubes. One tube consists of 7 segments. After it's fully packed, each edge will be 2 meters longer than before. So our frame unit consists of the corner-based structures for transforming and rolling, electromagnetic joints for climbing and structural locking, telescoping tubes for expansion, and elastic membranes to seal the gaps. We looked at sugar response to post-disaster scenarios, and we used the same principle of partitioning the safe space using frames. We added vertical and horizontal tiles to our system to form the macro and form space. A set of 9 tiles can be packed inside a fully mobile unit. Each tile has a square meter. So every living unit delivers a 9 square meters functional space. We are using different kinds of tiles to form floors, internal and external partitions, with a soft and a rigid part on opposite side. And we are also using transparent ones to create windows and glazing walls. We're using illuminations as a silent language to convey occupations, paths, targets, and inflatable furnitures. Translucent and blend materials are used in a way that humans will get to sense the existing of others while maintaining the necessary privacy. We looked at ways of populating our space with furniture, and we found inflatables to be the cheapest and the most optimal way to generate shape. Tiles can inflate when activated and deflate afterwards to form pop-up furniture. We also worked on a physical model made of steel. We firstly did the corner joints and then the telescopes. End up with a transformable frame.
With embedded visual sensor and interface system, units can sense each other in certain range and share information. They exchange each other's roles and tasks and reschedule sequence to avoid collision. Our system can continuously adapt to the changing environments, especially to the aftershocks of the disaster. In our system, there is a continuous interaction between the units and their users, the users being aware of the unit's condition and the units responding to users' needs. Tiles are following users' commands, door and window opening and furniture inflating. In turn, units interface with people by using the lighting system. Green lights guide people to certain direction, strong that units are activated and being in use, and low lights mean units are free and available. Space function as hospital in order for disaster injuries to get rest and treatment. Consequently, the space changes its configuration from open shed to an enclosed one. And in normal living mode, public area provides flexible space quality to fulfill multiple social demands. Using inflatable tile strategy, units can change from single room to double room and family room according to the requirements. And in this way, the system can continuously reconfigure according to the increasing number of people to be accommodated. The transformable frame and tile units can be used to produce elevators within our system, giving flexibility to 3D structure. The location of the vertical transports is temporary and flexible, and neighboring space formation continuously reconfigured to adapt to the changes. Users follow the get path to certain direction and target. Alongside, units get activated and furniture pops up for getting relieved from occupying. With the blend light material, people get to sense the existing of others, but also maintain privacy.
We analyzed real case scenarios, and we chose the earthquake that happened a few months ago in Turkey as the context to digitally test our system. To summarize the life cycle of our system, our units, when activated, autonomously transform in order to leave the warehouses towards the nearest safe zone. On the way, the units scan the map of the surroundings in real time and adapt collectively to overcome the found challenges. When reaching the safe zones, the units calculate the growth boundary and the exact location of the future 3D matrix grid. Using cellular automata and pathfinding models, the units aggregate and form housing clusters that continuously reconfigure to adapt and readapt to humans' needs. The same symbiotic relationship between the tiles and the frames can generate multiple space typologies by changing their position, shape, light, and color. The housing clusters that are generated by our system are together forming an autonomous, mobile, and adaptive organism that can frame a social ecology where architecture and humans are in a direct and indirect dialogue through architectural interfaces.
Thanks to all of our tutors and helpers. That's all of the presentation. Thank you for listening.
Thanks, guys, for that. Yeah, we'll open it up for conversation.
Happy to kick off. Really excellent presentation, and I think it has so many elements that are truly responding to a lot of the challenges of post-disaster after an earthquake, the adaptability to obstacles, the flexibility between a frame and the solid unit. There is a very nice dynamic in terms of the self-organizing, but also the human agency in terms of adapting. A few questions to I guess raise and consider is you look upon the flexibility, especially to work around obstacles by stacking. You talked a little bit about safe zones but also the possibility of aftershocks. It's interesting, a big challenge with creating a structure which is so transformable and mobile in this specific situation is looking at its structural characteristics and rigidity and robustness to what could be potential. It could actually be affected by aftershocks, and how would it perform towards that, and how safe it will be. Also, you talked really nicely about the ability to create open and closed space and reconfigure the spaces. It'd be interesting to understand how people would move from one level to another when you're looking at stacking and looking at the possibility of creating more levels for higher density. Again, also what was really nice to see is that you looked at the full cycle of where these elements are going to be stored, how they come in from the warehouses, how they are distributed. An interesting aspect to that is if you're actually looking at this system allowing for a very large expansion of a temporary settlement, which could have a large area and different layers, is how do you distribute supplies And how do you distribute access to water, access to energy? How could these networks and channels also be flexible as a system itself and integrated into it, so that you don't have to come out of the axis of the settlement to access supplies. Those are just a few of the questions, but really great presentation. Thanks, guys.
If I may continue on that. I really appreciate also the presentation, and it raises a lot of these inspiring questions. How could life operate in such a structure, and how these housing clusters that form these kinds of adaptive organisms build those social scenarios in it, especially as was said also by Nasia, in this kind of aftershock condition, that it would be good to maybe look more into the psychological aspects of trauma, and this kind of psychological need of security, maybe, and also then in quite practical terms look at how the wayfinding would take place in such a structure when people are actually in shock. Yet that the adaptive organism of this kind of housing clusters is constantly changing and adapting to people coming in or moving out. So I think that one of the questions is about this kind of securing the quite individual level, the kind of personal needs of the inhabitants, and then on the other hand, kind of securing this kind of calm and well-functioning this kind of centralized control system, and aiming at balancing in between the two. I was also thinking about the resource management system while I was looking at the presentation, and as Nasia pointed out, this supply distribution is also it could be a very interesting aspect to look at, including water and food and waste management and energy production. And of course, I'm wondering if using nature's intelligence to inform these units and the operation of the infrastructure, if that could be helpful. I was also thinking that, as I understand, these units are packed up and stored in a warehouse during the normal times, that could there be use for these modules or units in between the catastrophes? And moving beyond that question, could these modules be used for other emergencies? Because you spoke of earthquakes, but there are these different kinds of situations and crises where we really need to build urban resilience and of our society. So I was wondering, could these elements or units or modules, how to push further their functionality for different needs that we might have. So that's briefly my comments. Thanks.
Yeah, I found it bold that you were also physically prototyping this scenario, sort of some of the discrete elements of which the project consists of. But I find the implementation quite convincing. But the scenario that is being implemented is, for me, insufficiently clear. So, for instance, the fact that you have these mobile units, right? I mean, a scenario that comes to mind is, for instance, extracting the victims of such a catastrophe while giving them care simultaneously, right? That seems a scenario that could be implemented with the means that is provided by this technology. Though on the other hand, is that in such a scenario, I think you would want to extract victims to a centralized place, right? While this technology is really allowing you to deal with decentralized systems. So, for instance, something that comes to mind is farming, right? Now, for instance, on the farm, all of the resources of the farm are centralized. Well, there's such a vast area that needs to be managed, where a decentralized system could make a lot of sense. So, while on the implementation level, I find it quite convincing, I find the overall scenario that still addresses some questions.
Yeah, I think, I mean, a great project. I don't think it's about injured people, etc. This is about what you would otherwise have, these sports hall with mattresses and camping, and then the more flexible and upgraded version of that. I mean, I still wanted to pick up, I mean, the lightness, obviously, which is required for that agility, then maybe becomes a question mark when it comes to stability, and also shielding against weather conditions. I mean, there's something one needs to. It feels unrealistic in a sense with the lightness and minimalism of lightness of structure, minimalism of enveloping. Whether you can actually deliver a robust enough shelter, which withstand weather conditions and maybe even aftershocks, as was mentioned. So, but I think otherwise, in terms of the scenario, for me, is convincing enough that you have to literally evacuate a whole urban fabric, a whole district, a whole part of the city, and then it's much better to have a decentralized, I guess, kind of ability to stay close, and of course there's also then supply issues, water and so on, but these are secondary. So I think in terms of scenario, I'm fascinated in terms of the scanning and formation of scanning of space and formation of response habitats is I think is convincing to me in terms of a strategy.
If I can continue on that a bit, Patrick, I agree that scenario of moving into a sports hall, I think that's quite successful. I think that is proven that it's a good system, right? And I think also the hijacking of that system of how the organization, the agency of the factory is organized, I think that's also very nice and very clever how this is being moved into this refugee scenario. But I would wonder what would be then to prove that this system is superior than any other modular partitioning system, right? I think there is the flexibility, the lightness, I think the adaptability is good, and I can see that these modules could also show different conditions with different structural parameters when they have to be more vertical. But the area that I think could make the system superior to any other sort of refugee is how this could adapt to more difficult terrains, right? So you can deploy them into really difficult scenarios where you don't have enough capacity in sports halls or in really flat plains. And that this modular play could really help either make it more vertical, more squeezed, really adapt to multiple topographic challenges, right? I think that could be maybe an added ambition to that will take this model as this is better, and this already using more technology and more adaptability with the agency to a more sophisticated condition. I think overall, and I also liked a lot the test, the physical module that you guys developed. I think that starts showing the good understanding of the constraints of this structure, right? Which is, it will come back to what you were saying, Patrick, that it doesn't show that it could stand more than one floor and not strong wind conditions. But I think it's a good way to start testing those principles, right? So I think overall it's quite a nice project and very relevant as well. So congratulations.
Can I follow up on some of these comments? I really also very much appreciate the project, and very much appreciate that you guys were actually eager to prototype it at 1-to-1 scale, even though it was only the transformable structure and not the elements with it. So, but it's really, really great. I have the tendency to agree a little bit with Jelle in relation to the scenario, although I think that and also, let's say, your units are so modular that it's very difficult for me to imagine that they would be deployed anywhere, no matter what the topography would be. Creating this kind of perfect world in which you can start creating stacks on a completely flat ground. On the contrary, I think that maybe in relation to the scenario, you could think about, for instance, now with COVID-19, there is plenty of empty big spaces that have been used for temporary hospitals, for instance. In Spain, we have used all these large convention centers now that there are no world fairs and places like this to actually deploy hospital areas. So your system would definitely be super suitable for those places. Or for instance, empty sports fields, or places that per se are already flat. And then maybe the kind of rapid deployment of these robotic units would be absolutely super. And also in relation to durability, these emergency scenarios like earthquakes, we all know that things do not get resolved in question of weeks, but actually it's much more months and even years before people can return to a normal situation, which therefore would very much justify the investment in your, let's say, more expensive units than tents, let's say, because you are thinking on long term. And it would be very interesting then that the scenario that you plot out is actually almost like what happens when these units are slowly being abandoned, if you want, so that the reconfiguration happens post facto. As people return to their homes, as people return, that the use of this quickly deployed structure actually begins to change over time, but in a kind of longer time frame, and not so much on the first emergency response. So I think there is a lot of opportunities in your project for very different scenarios. Not only that of earthquakes, but let's say pandemic being another one. And for sure, there is a lot of potential. So thank you.
Yeah, I really liked it also. I think it was really clever and creative. And I also really liked that you prototyped and tested it. I think I'll just echo a little bit of what others have said. So first of all, I wonder if you've thought about smart materials and smart fabrics. So we've had a little bit of discussion on topography and local environment. So how to think about the materials being adaptable to different kinds of weather conditions, climatic conditions, and also obviously different scenarios. The second thing is obviously, I wonder if you're going to think a little bit about it might not just be an earthquake. Why are people in this housing, and what do you need to account for? Is it safety? Is it cold? Is it medical equipment? Is it isolation? As Marta might have referenced, COVID, keeping people away from each other, not close to each other. What would actually work best in terms of the layout based on the situation at hand? I really think you should think about local resources, nature and technology, local skills. This might actually apply to multiple regions across the world, but don't forget that most disaster housing actually just doesn't go away. Lots of
disaster housing ends up becoming permanent cities, towns, settlements all over the world, and millions of people now live in these. So can you think about a scenario where ideally you might want to take it away, but what if it becomes something that's more permanent? How might it be used? It might become storage rooms or bathrooms, and it would be very interesting to think about in your design, accounting for that, and also accounting for environmental impact. Because if this is just thrown away somewhere onto landfill, what does that mean? What are the distribution channels at hand to both deploy, set these up, and also to clear them up and take them away? Who's going to be responsible? Who are the stakeholders? So I think it's really interesting question. So, and as you continue to think through it.
Yeah, just I kind of want to pick up on some of these comments because I think a lot of the things that were motivating the project was really an acknowledgement, I think, of a lot of the durational aspects of how the existing emergency response systems, even if they have been designed as something quite deployable and something that can be sent out, the social and the political conditions basically make them things that are very long-term, like Suhair and Marta are mentioning. I think the other thing, I think one of the models that we were trying to look at was if we have strategies that have a kind of semi-autonomous nature to it, that those things can be rapidly done in a much more real-time way and somehow navigate some of the stuff. We were looking at things like Marta was mentioning. The Excel Center, for example, in London was used as a strategy, and models like Shiguru Ban's project with paper tubes, I mean, is an amazing project and one of the critical references. I think the problem with that is that it has a demand, like a lot of these systems have, that you either have to send specialized kind of forces like in the States to wreck them, or it demands a lot of local kind of attention, where at the scale and the magnitude, like the strategic strategies that we can see in terms of like warehouse sorting machines and using a lot of the software strategies with some of the things like textiles and other materials, which are quite affordable, that we could have these smart materials being able to participate in this. I think a lot of the things that are being raised in terms of the structure has been something that has been a continuous kind of struggle in terms of looking at that with AKT and trying to find a balance in terms of lightness and modularity, but also with the idea that it could be an infrastructure post-disaster that could be customized. And that kind of almost goes back to Yele's comment on the previous theme about constant, which is if you could create a scaffolding using the structure for some of these longer term kind of domestic scenarios that are very much part of a lot of these kind of social scenarios, that it would offer something to it. It did remind me when I was looking at the animations, there was a photography shop in New York, it's still existing, I believe, called B&H, and it was a really large supply house. And when I look at some of the animations of the partition sliding, it would be interesting to look at the management system strategies. In B&H, they used to have all of the products on a track system on the ceiling, so that it's one of the largest kind of resources for photography supply in New York on 34th Street. And yet at the same time, you had all of these very, quite crude systems, but tracking systems, moving goods and things really to the cashiers and everything. And I was always amazed by that operation because of how simple it was and how powerful it could be. So I think the intuition to look at the kind of software models that are really managing these things and customizing that, I think, is the attention of the kind of high-tech aspect of implementation. But I do commend the team for looking. I'm not exactly sure what the full disclosure of the material properties are. They did start with these kind of steel fabrications. I think also to try to understand the geometry. I'm not sure that this is a multi-story system. I think it biases for sure the horizontality, not to have vertical circulation. But I think as an overall, I'm quite satisfied with where you guys are going. But I think a lot of the comments, I think, are really important to maybe look beyond this particular scenario more prototypically and see the opportunities. Because, for example, if you are creating this project in an existing building scenario, which is what usually is happening at the moment, maybe the ability of deploying a different kind of internal partitioning system, that is really lightweight is something that can be done. If that's compromised, you can deploy a different kind of strategy. So how you attach tiling logics to the base infrastructure, almost like a plug and play system that would be deployed, I think strategically could be also things that you could consider. Overall, I think the conversation has been, I think, quite good around these subjects, but it's something that is demanding that I think you guys should make the investment to push a bit further in terms of articulating and communicating plausible scenarios. I think if you introduced one or two more scenarios, I think that the project then just begins to shape itself as something that really could actively be considered in some of these things. So I would encourage you to do that, basically. And in the next 2 weeks, I think, without the pressures of actually production for a presentation, I think it's important to table some of these comments and to try to see how you would structure your document in some ways to make that legible.
Theo, is there time for me to point out to a contradiction?
Of course.
So it seems that there's a kind of Moses Mountain duality, right? Is that, do the resources come to the needy, or do the needy come to the resources, right? One way or the other. And the proposition is almost too creative, right? There were these strong references of the Amazon and the other robots, where it's really an architecture that is optimized for robotics, right? For resource distribution.
Sure.
So here, in a sense, the patients, which are kind of immobilized by definition, in a sense, right, have to move through the building, where you would sort of also, it would be also interesting to consider in a more dualistic approach, perhaps, to see what if the layer on top of the persons in the in this temporal hospital would be addressed by an infrastructure of mobile robots on top of them, such that the resource would come to the needy rather than the reverse.
Yeah, no, I mean, I echo all of that. And my suggestion for the students are, I mean, they focused a lot on the deployability, but on the complexities of how that goes from the immediate response, like Marta was mentioning, to something that has longer standing duration. I think those scenarios are very important to show what transformation is. So as the system is not being used, how it compartmentalized, how it would restructure, and decisions about maybe how this could become a scaffold for something that is maybe more semi-permanent. I think that takes the project into a different trajectory that I think is as necessary, I think, when you have this as a seed of an organizational strategy to open up maybe future research for the team as well. So I think with a lot of these projects, at least in my studio, they're kind of open frameworks. So I think the scenario is primarily there to test. And I guess what I'm encouraging the students is to take the feedback that you guys have given and these different opportunities, and to see that as a critical part of the way they consider not only their practice, but where actually the design research's value could be placed. But no, thank you for the comments. If there's not any other comments for this project, then maybe we can continue with the next one. Okay, thanks. Can we get the third team to present?
Yes, Mason should be ready.
Yeah,
it's connected, yes.
Share the screen.
Thank you, thank you.
This is one of Patrick and Pierre's. Thanks, guys. You can start when you're ready.
Okay. Hello, everyone. We are Group Morpheus from Patrick Schumacher's studio. My name is Mason, and with me is Jan, Yuri, and Yushan. Morpheus envision a homogeneous multi-alpha urbanism through a morphological process to reach a social ecology as a new urban fabric. It is a response to the environmental driven by the extreme climates such as flooding as an input to transform the monotonous industrial cities built in chaos to a hyperdensified vertical field where the space is determined by dynamic programs and perceived by observed experience. Moorfield proposed a new high-rise district between the City of London and Canary Wharf and generate a differential tectonic formation across Unity. Flood risk has been a major issue for London, and its probability is increasing with extreme climate change and its potential consequences by population growth. The River Thames is easy to be influenced by tides and surface water. This issue is a major concern for any future development and encouraged to derive a strategy for flexible systems in urban scale that provide adaptability instead of only protection. Second environmental aspect is the wind, which is highly considerable in any hyperdensity development in London. We are inspired by the nature and explore how to provide responsive kinetic facade system for controlling the amount of sun exposure. For social aspect, we explore to bring gathering the atmosphere of the urban space into the towers. And we also use topology optimization as the means for design process. Based on the environmental aspects, from flood to wind to sunlight exposure, we strategize a process that is adaptive, responsive, and dynamic to the context and to the environment. Our proposal categorized into the site strategy, tower topology, and prototyping in single and group towers. We explored the relationship between the ground, river, and towers. We came up with a layering strategy. The ground dropping can store the water during the flooding. Lifting podium let water to pass underneath, and our strategy is a combination of both. Our site is located in Wapping, London. It is very close to the center of London, and there are many landmarks around, such as Shard and London Bridge. There is also a high-rise office district close to the site. The main roads and railways cross it from the west to the east. And there are several docks inside the site which are connected with the Thames, and most of the area at risk of flooding. Some landmarks in the site will be preserved, and the garden will be regenerated.
Mason, I'm sorry to interrupt, but there seems to be some clicking sound. Do we know what that is?
Yes. Okay. But you heard me before, right?
No, we're hearing you fine. It's just
okay.
I think it's distracting some of the critics while you're presenting. If it's something that we can address, people will concentrate better on your presentation.
Okay.
Sorry to interrupt. Yeah.
The next is site strategy.
Firstly, we did a flood simulation based on the touring of the site. From the simulation, we found the water entered the site from the basins and became in the site, eventually causing half of the site to be flooded. In this simulation, the basins were connected to form a waterway that quickly drained the water away rather than store in the site. So we used the same amount of water to examine the site with an internal waterway to verify our conjecture. By comparing these two simulations, it can be seen that the waterway effectively reduced the site flooding. Based on the existing landmarks, green areas, the position of the river and the roads, we'd like to use a generative language to find a new morphology for the site. For example, about the road system, we find a new network to connect the surroundings, but leave some space for the existing parks, rivers, and historical buildings. And the simulation will give us a reasonable guidance for the road system. Also, we can extract the main paths and rebuild them. And from the same logic, we can organize the pedestrian and landscape system together and combine them to figure out the whole mega integration. Overlaying the different layers of road system, landscape, and pedestrian with the waterway translates to the morphological spatial organization. And as site has three docks and basins, normally they act as the multifunctional leisure spaces, and while the water level rises, they can handle normal surface water or cloud bursts. And by raising the water level during the flooding, the adaptive landscape will connect the basins into continuous water system, which can reduce the damage and finally join two dams through the basins. And here is shown the adaptive landscape respond to different layers. This is a normal situation and when water situation. And we use the evolutionary engine to calculate the height and initial shape of towers, which we use later for structural optimization. We chose 5 objectives for calculation, including minimum wind load and minimum sunlight in summer. Since these 2 objectives tend to reduce volume and height, so we also introduce maximum height and volume to get various forms. In addition, with shorter connection structure of cluster to save materials. The tower's height can vary from 200 to 400 meters and diameter can change from 50 to 70 meters. We selected 6 arrangements out of 5,000 results. They fit well in the minimum wind load and with balanced data in other aspects. The skyline is another filter. Due to the low height of the surrounding, we consider the higher tower concentrated in the middle, and the skyline in another direction, we place the lower tower near the riverbank, and the height of tower rises gradually from south to north, which ensure open view for the northern side. The final result we chose meet all the consideration, and different grouping can be observed from different perspectives.
Our tower topology is divided into single and group towers with the steel and concrete material. We use a structure optimization by 4 tools like Millipede, Amoeba, Pregreen, and Topo. Each one has potential to give the variety of results. We apply different methodology to translate it to a steel and concrete structure. The first methodology is solid remodeling, the optimization results, and then materialize it into concrete structure. We find a way to split the structure into precast pieces. For an integrated system, we explore the method to tie the integral and external structure as a combination of steel and concrete that can cover larger spans. And slabs connect all the structure to avoid backlink. Also, a skin structure system considered to hold the glazing system. And here is a sequential section shows the overall structure. In type, In type B tower, we extract the load path pattern from the result and remodel it into exact skeleton structure.
So sorry, I forgot to open the microphone. Okay, based on the same logic, we select 5 of the results to remodel as exoskeleton. Besides the exoskeleton, endoskeleton is also considered to support the tower. We developed 2 types of internal structure, concrete structure and steel endoskeleton. To generate internal structure, we set anchor points and shrink the exoskeleton mesh inspired by soap fill to create the internal mesh, and remodel the mesh as internal structure. We combine the exoskeleton and internal structure together as a complete structure. For the steel internal structure, we set load points within the exoskeleton and generate a steel structure according to those load points.
In Type C tower, we applied vertical and horizontal load to simulate the force condition, and then we extract the load path pattern from the result. By controlling the parameters of the domain, we got a large number of experimental results of structural optimization. And the intersection of the horizontal and vertical structure system can give us a series of structural nodes. And the structure forms an atrium space that carries the traffic, and the structural system is also contribute to the circulation system.
This structural morphology densifies the upper and middle parts of the tower to release some space at the ground level to adapt the flood situation. And the spatial layout of this structure is flexible and suitable for the vertical communities.
In the first type, we use asymmetric volume for structural optimization. This initial shape came from evolutionary engine, and according to this initial shape and different programs inside the tower, we design different plans prototypes, which initiate the location of the point load. Based on the rough structure, we translate the structure to get more flexible and controllable forms. We put control points to represent the joint, which attract structural lines to form new joints and same position. The form of tower can be controlled parametrically. And different atriums are distributed among the floor with different functions. The huge atrium in the office area creates a dynamic and efficient office space. And the shading system on the south facade greatly reduces the solar radiation in summer. The atrium of residential area enhances the communication atmosphere between residents. Since the translation inevitably reduces the rationality of the structure, we add a secondary structure system to make those exoskeleton feasible. The main structure is exoskeleton, and we also have inner skeleton that surrounds the atrium. The secondary structure is ring beams placed every 2 floors to reduce buckling. And in addition, the inner columns are added to reduce the span of beams, avoiding the buckling inside the tower. And we use crumbar to test the stability of the whole system under area vertical load, wind load, and gravity. And the influence of wind load, deflection happens on the top, and the top displacement is 38.8 centimeters, which is smaller than the maximum allowable displacement.
Next is the tower topology for the steel structure. Considering the space and the whole structure system, in this type, we combine the external skeleton with high performance on spatiality and the internal structure, which acts as the vertical traffic core. And the slab tied all together to make the facade structure. Regarding to the technology, we considered cast steel joint to connect the main structure with substructure.
The second type of the steel structure, we explored the variety of translation of an optimization result into a steel materialization. Based on the extracted structure nodes and load paths, we regenerated new morphology. In this approach, we have the control on the number and the profile of the structural elements. Then we found the control on the thickness of the exoskeleton structure. The third step was to add more complexity and variation into the tower body by using a bundling system of structural elements. With this morphological language, we got variety across unity and diversity in facade formation while coherency by bundling methodology. In the second type, we look for a special organization out of configuration of a steel structure and a technique that we can get variation of section plans, number of the members, and their size. These sequential sections show the variety of the special organization outcomes. Some steel skeleton structure that forms multiple alternatives. This is how the body and the skeleton forms together. With the same logic, this is how the skin covers the skeleton to form another type of towers. And the way the internal and external bones structure with the circulation cores come together. And the coherency of all the elements in the one tower. The diverse and coherent spatial organization of the floor plans shape in one morphology give us the potential to embrace the different program inside. To get more transparency and lighter structure, we propose the lattice structure. Each side of the structure works as a mega structure column that can carry the load of the widest spans and also house the space. Mesh structure type is also a combination of the steel frames that connect with a series of rings that are tied together by the mesh structure. Similar to lattice structure, has more transparency, less material usage, and lighter weight. And the blow-up view the structure layers and cladding. Group towers. For the group towers topology, we first studied the bridging formation by optimization method, which provided us with alternative connection system. And with that logic, we explored twin towers. The next step was to find the topology of the group towers through optimization process. And it gave us 4 types: twin towers, group towers, branching, and bridging tower. As our aim is to hyperdensify the upper part of the towers and lift off the ground due to flooding, the branching tower have this potential to sit on the 6 towers but have 7 towers on the top. We also explored the orientation of the towers as a cluster. We started with cluster topology optimization. Then we applied a structural optimization on the topology result to find cluster structure. We used a combination of the rings and bundled steel pipes, which is bending at the structural nodes. This structure is lighter and translucent. Some columns carry the vertical circulation, and the slab tied all the structure together with providing certain voids for space communication. Finally, it will cover by a skin structure that holds the glazing system as well. And this is the result of the Metropolitan Tower. During the flooding disaster, people might be stuck in the building for hours or days. These cluster towers work as a Metropolitan Tower that include city-like programs and facilities for people to move and evacuate from tower to tower to be in a safe area. Also, people can access to the marketplace, the sports center, theater, pubs, and roof gardens. Here is the final result of the Metropolitan Tower with roof gardens, the gathering spaces, and running lanes, pools, and supported by helipads.
The next part is our prototyping. To find the location and generate the shape of the atrium, we use an parametric way by adding the center points of the columns and the floor as an input to create a streamline that transforms the void and slab shape. Similarly, the position of charge points are changed with the different section of the structure, which have gave us 3 typologies with the atrium in the center. The atrium expands from the center to the boundary, and the last is the atrium distributed in different places on the border. This typology of atrium and slabs has been adapted to different programs in the towers. The generated streamline can be also translated to the pattern of the rib beams. Tower circulation. We set the circulation along the thicker parts of the structure. The long-range circulation runs from the bottom to the top. It is mainly for apartment units and the hotel. Mid-range circulations are considered for the office spaces, and the short-range are for the communal and commercial space. According to different types of circulation, the high-speed elevator is inserted in the biggest size of the columns. The mid-speed elevator for the mid-range circulation is half enclosed by the column, and the low-speed elevator attached to the smaller column and move along the tracks. Here it shows how different types of elevator work together in different areas.
Sky lobbies. We explored the idea of a gathering that happened in the urban spaces to bring the atmosphere of the public plaza into the tower. These floating spaces with green area and the continuous views are accessible in a certain level through bridges and provide the gathering atmosphere. Here is a section how the floating space. With the decentralizing the circulation cores and open up the space and views, we provide the sky lobbies and open plazas for each tower for people gathering while they are safe during the flooding event. Drone Plaza. During the flooding event, we want to provide people with access to the outside marketplace that they can't survive in the towers for hours or days during the disaster. So we provide some areas in the towers as a drone plaza that people can pick up the item brought by drones.
And for shading system, where we want more sunlight in north facade, on the south facade, we have 3 methods to reduce sun radiation. The first is folding, to form concave surfaces and take advantage of self-shading. And when we have balcony on some floors, it will act as shading unit. And the third way is using the shading system. Oh, sorry. Dynamic skin is used where the sun radiation is the highest. The angle and protruding length of shading unit depends on the direction and intensity of sunlight. On the surfaces with less sun radiation, we use static shading system. Due to the shape and different materials of the sunshade unit, different effects can be perceived from different perspectives. As for tower program, in the area of retail and restaurant, we want people to focus more on internal commercial activities, so we only have internal atrium to have more communication between different floors. And as for the plan for office, we have large open atrium and outdoor activity space to create more dynamic office. Also, we have an elevator to carry people up to the residential area or down to the ground, and 4 internal elevators have people to travel between different layers in the office area. The plan for hotel, we have balcony in the outer ring, so more room will have better view. And in the residential area, we have 3 apartments each floor, and each apartment has its own balcony. The large apartment is designed for the family. Based on the floor zone simulation, we divide the site into high-risk area with group tower, medium-risk area with tower and podium, and low-risk area with single towers. In the safer area, we consider the public program at the bottom, and along the inland river, which is the most dynamic area with plazas and gardens, the proportion of commercial office and cultural function is gradually switched to more private functions such as residential and medical programs on the northern side. Also, we have sky garden every 10 floors. In the high-risk area, when the water level rises, the group tower will become a living system that can operate independently. So the public programs are also distributed near the breathing system, and residential functions are arranged in quieter floors.
This part is about urban networking system. The topographical differences of site from south to north lead to different strategies of each part. In the south, which is seriously affected by the flood, the clustered towers form a self-sufficient circulation system, and in the north, the mega system, podium and ground form a vertical and horizontal network with towers. To find the podium morphology, we positioned the energy inflow based on the direction of the traffic flow line and set energy vortex at the tower location to reserve space for the courtyard around the tower. And the streamline energy field has been transformed to a podium as a networking system that connects the towers horizontally. So we use the distribution of particles to materialize the invisible energy into tangible space. And these podiums act as the connection with the towers, ground area, and road system, integrate the relatively separate vertical towers and horizontal direction of the site. And we provided at least one entrance plaza for each tower. The walkable roof increases the accessibility of towers when the water level rises, and enhance the flexibility of space and moving paths. We drive along the traffic flow on the ground layer, and we can get off at the entrance plaza connected with the podium. The overall view shows the circulation between the mega roadway, the podium, and the tower. And we can go through the plaza and take the lift on the ground layer to go upstairs to the fourth floor. When we go out the tower, we will arrive at the garden of the podium. Then we pass the commercial part, and we can join the outdoor leisure space. Walk through the path of the roof, we can reach all the office parts. And then when we go downstairs, we'll return to the entrance. Also, we can directly arrive the elevated layer from the ground.
Proposal. Top view shows the contextuality of the new generated field and the trace of the fluidity effect of the water through the landscape morphology. This aerial view shows the gradual changing of the height from south to north and from cluster to the single towers. A view from the east and river banks. The overall view shows the variety of the structure while coherency of the whole site. A view from the west, which shows the heterogeneous fluid landscape and the networking system between different parts of the site. A view from the balcony looking to the east. A view from the inside of the tower looking to the west. And this image shows how the rainwater can be stored to provide safe area to connect the towers. When we have flooding event, people can access to the safer area of the north side through above ground bridges. This view, the view to water catchment area between south and north side. When other buildings are flooded, our towers and facilities still can be survived and work as usual.
Responding and adapting to environmental aspects like wind and sunlight provides variety while unified language. From different users' perspectives, users can have different experience of space differentiation. All the roof of podiums are workable, which also act as plaza for multiple activities. People can enter the tower from the ground or through the platform of the podium. Walking through the lobby, we get to the office area. The local tower provides more open and dynamic office space, which contributes to the collaborative integration. Commercial programs such as stores and restaurants are located on the higher floors. The large atrium here creates a more fluid and dynamic commercial space. And the living space is on the top of the tower. The lobby here carrying public activities provides more communication for residents. Go through the lobby, we get to the apartment. Plazas and gardens are densely distributed along the inland river, where people can enjoy leisurely outdoor time. From morning to the evening.
This outdoor space provides a gathering and active place for the workers and residents.
When a heavy rain or flood happens, those plazas at different layers also work as water catchment, protecting other areas. The elevated road system can still connect all the blocks. Here is a top view of combination of 4 groups proposal, and a video to show the overall view. Thank you very much for listening.
Thanks, guys, for that. We can open up it for a conversation.
To start, maybe to give some initial comments, yeah?
Yes, please.
I think overall, just to say, it is very impressive, right? The amount of work developed, the clarity of the presentation, I think it's quite commendable. You guys reached a lot of depth on the project, on the research, and I think it's very well communicated. I really was very pleased to see when you went so deep on the catalog, how maybe when you were starting too much of free-form intuition, then adding the structural optimization, the towers even became much more legible, much more elegant, and much more clear to understand that you were really taking those parameters on board to develop the actual exoskeleton structure, right? And I think this got then reinforced by the richness that you implement not only at the facade skin, but how you could really play with pushing in the slabs, creating multiple social spaces, and I think that interaction and sort of richness of spatial qualities within a tower is quite exciting to test and to explore. And I think you guys do that at a very impressive level, right? I think the distinction between steel and concrete is good to have. I don't think it comes out that strong, but I think there is so much level of richness that it becomes also, maybe it takes a step to the side because you guys achieve so much, which I think it defines the richness, and even that these public spaces, atriums, I think they become quite legible and coherent, which reinforces the overall strength of the composition. I don't like or understand why sometimes you made a symmetric tower from the horizontal to the top, that you will have the same response to the ground as you will have to the top of tower. I think that's not what you will achieve either by optimizing or by really creating spatial coherency or the program legibility. But I think on the overall, it comes out quite strong, right? I think even maybe the weakest part for me is the ground condition and the flooding argument. So I think you do create very nice fluid podium and landscape conditions, but how the flooding really adapts to it or is shielding the towers, I think it doesn't go as much as in depth. But obviously, you cannot solve everything in this stage. So, but congratulations, I think it's quite successful, quite interesting, and quite impressive, the amount of work and development. So well done.
If I may continue on this, I also very much enjoyed the convincing integration of this pedestrian and flooded landscape system. I think it's quite a beautiful way of generating this adaptive landscape with responsive layers. I was wondering though, what happens underneath the water level? That how do these towers continue to stand up in these kind of evolving climate conditions? And while listening to this very convincing and beautiful presentation, I was starting to wonder whether flooding is the only challenge to consider. What else is out there? And also wondering about the life beyond concrete and steel. That what about this flooded? How does the flooded condition affect vegetation, biodiversity, etc.? So I was trying to kind of see it beyond the provided structure. and thereupon the questions arise about harnessing these possibilities of vertical living. Well, the first questions are about food and energy production, and then as we also spoke of it yesterday, this taking infrastructure as a cultural project. But beyond that, what is really this kind of long-term sustainability of such structures in terms of the ecological challenges that we are facing? So I guess the main question to me is that it's as if we see the end result, but what about actual construction in water? That how are these structures constructed, and what are the issues to be solved there? Because I really enjoyed this very well considered class orientation and optimization exercise, and I think the richness of spatial possibilities is very, very inspiring. But maybe there is opportunity to look into further possibilities of use cases, and also interrogate these future ways of work and living, also in terms of livable public space as extension of this well-crafted interior living space. So yeah, these are some of the questions that popped into mind. Thank you.
Thank you.
Okay, if nobody else. Okay, you go, Martha.
No, I wanted to bring back some of the comments from yesterday's conversation on a similar project about. Well, first of all, I want to say that it's the last renderings about the project in fog at night are just stunning. I have to say it's so beautiful to see the kind of final representation of the project. Is really inspiring. So thank you very much for this. Sometimes though, during the presentation of the project, sometimes I felt like I'm looking at 4 different projects. And I had a little bit of a difficult time myself to stay connected to the project, because there were, it seemed like there were 4 different representations of that project. So I just want to, in some ways, commend you for the communication, especially at the end. And in some ways, sometimes it was a little bit difficult to follow. But having said that, I think that personally, I feel that you have done a great effort in trying to connect, let's say, your massive implementation to the existing neighborhood. That is something that yesterday was less evident, and today in this project is more carefully crafted. That is something that I really appreciate. Maybe what I can say is that the movement on your massing, on your landscape is conceived more along the river, and not so much as something to access the river from the other side of town, let's say, not along, but across. And maybe that part could be better developed. And in relation to the comment yesterday about how these, you can think about this project in 2 ways, and one is as a kind of problem solving to the potential flooding, and that you do very well, and the other one is a kind of more opportunistic, if you want, is to create opportunities that are connected from the proximity to the water. And I think that in that front is a little bit less developed, and also, like, how does it become a major infrastructure for the city in relation to water management, so that is not only a project that is thought internally to connect between the towers, to move pedestrians on the side, etc., but that this major scale can also provide something that is really almost like a major infrastructure for the city for water management. And I think that's really the great potential of these projects. I believe, Patrick, that they have the potential to do something else than being a kind of massive intervention, and to kind of organize the circulation on the site, but to actually do something at a much bigger scale than what they are in relation to water management. So thank you very much for this.
Thank you.
I mean, it reminds me of one of the definitions of art, to confront the contemporary world with another possible world, but then to use visual phenomenal translation to make that compelling, make that tangible, make that an aspiration one can buy into. I think that's what is happening. I mean, it's very touching for me to see this. It's very rewarding to see the level of resolution and originality and beauty. You know, the all the way to the interior spaces, the transparency of these towers we've been talking about, the porosity. The realism of this could be discussed in terms of the elevator structure. I love that image where you have you in that a highly differentiated atrium space, and nearly every column is kind of sponsors one or two elevators. The differentiation of this is beautiful. I do think there are certain moments in the build-up which could have been brought home in the final as well. For instance, I love that moment when you had these big mega columns and mega structural members suddenly, maybe high up the tower, they get themselves dissolved into a filigree of framing, a bit like the Eiffel Tower. So that is a moment. I mean, Paolo was talking about the differentiation of concrete and steel, and that could have been more evident. I think there is it doesn't really need to be an all white kind of project. So it delivers desire. I mean, I love yesterday the way Ross was talking about being inspired with wanting more and more. Like, you know, the porosity of the structural elements themselves, the porosity of the floors. And when I look at just now the shading elements, they I feel they're beautiful, but they will not sufficiently differentiated as you go around from south, east, west, north. So there's lots of opportunity, the bleeding of solids into filigree. But it's stunning. I mean, and I think the landscape is lovely. I mean, by the way, it feels still quite vast on the ground. And so I was encouraging the teams to try even more density in some areas. We had this discussion. It's a landscape for cyclists and joggers. Maybe there should be zones of more intimacy as well, so they could rely on more density. But overall, it's just been. It's just, I'm so happy to watch this.
If I may add my comments, I really loved the fact that although we're talking about high density vertical architecture, you really approached it with a high level of horizontality and the connection at a horizontal level. Both at the landscape, at creating basically parallel landscapes that adapt to the fact that first ground level might become, might change in terms of its conditions. And also that you thought about it, you really approach it from the ground up, even though we're talking about vertical architecture, that you really didn't look at creating a network which responds a landscape which responds only to one state, but actually to the adaptation of the flooding, and that you looked at channeling the water, and that the water doesn't become a segregating element, but if anything, a connecting one. I think there's a lot of potential to open up there in terms of something Marta mentioned, you know, looking at water management. You talk about solar and wind, for example. You can look at hydropower and flows of the water in the landscape, and also how it can become also an alternative mobility network potentially. I mean, you've alluded to it, but overall, really the consideration of adaptation, these parallel landscapes that exist, and even at higher levels, when you looked at the cluster typology that created that horizontal connectivity, it really creates what Patrick said, porosity, but true connectivity of the vertical buildings, both between each other, but also with the existing landscape, and that it looks to be connected with the ground rather than departing from it. I'll say, as much as the connectivity with the ground creates such a nice level of warmth and the connectivity between the tiles, again, just in terms of just a visualization, it'd be great to see the material variation within the interiors, showing a little bit of that more humanity and variation that could create the diversity of the spaces and amplify them and resonate the diversity that you allow for. But generally, yeah, really exciting and a really nice way to approach it.
If I can contribute some thoughts, I mean, I think the project has been presented in a very convincing way. And I think the cinematic aspects of it, I think, lends itself to ways of potentially thinking about how you can kind of explore this maybe a bit further. I kind of want to pick up a couple of points that Veronica brought up in terms of use cases. I think there's a general tendency with large-scale urbanisms, and I think that this is an ongoing issue about how they're used, who they're for. And I think the opportunity to really communicate some of the intentions has to bypass the general kind of readings or aesthetics or these kind of aspects. And I think when we do have these kind of larger scale urban offerings, I think it's really important that we also kind of open up possibilities of how these things can kind of be utilized. Not only by the community that's going to be living there, but this is a piece of the city. And with that, I think, comes demands of actually somehow speaking about how this really does become part of a 24-hour living ecosystem that extends London and is really symbiotic in some ways. And that, I think, can't be left to the imagination. I obviously commend you for some of the rigor. I think one of the ways that this team has chosen to work is really been quite consistent. I mean, you came to a kind of ground condition, you developed it. And I think one of the things that I would ask you really in the next 2 weeks is just to really play out scenarios that really give this some life. I mean, some of the conversations that we had yesterday about resolution and about porosity at different scales, I think that becomes really important to kind of qualify what that actually really means when we have a densification, when we have these large territories, how this doesn't somehow reintroduce the problematics of undifferentiated or undefined large spaces where people are kind of lost. And I think that there are possibilities, but I think that they demand probably just as much of an effort as you guys continue to think about the projects and continue to work on things. But because you do have, I think, a certain flair for the cinematic, I think it's important to try to focus some of that on trying to give life to this architecture. I'm not suggesting that it's not there, but I think it's too easily dismissible as something that's very exclusive by some of the conversations. And I think you can be able to engage that in a really direct way and in a very contemporary way to really give life to actually what even vertical living is. I mean, there are aspects about how these buildings can be used in different ways and what opportunities are there. And to go to Martha's point about the 4 different strategies, I think that there are different opportunities in those different case studies. The towers that are much more mutually symbiotic and correlated, where you lose the individual autonomy of the vertical element, I think that lends itself in a different way to potentially different programming, different events. And I think the richness maybe in some of the acknowledgements of things like the Barbican Center and other places that have culture, different kinds of aspects embedded from the beginning as a kind of social imperative of what a development of a certain size and scale is. I think that that's really important. So I think that there are a lot of ways of discussing the project, and I think a lot has been discussed in terms of its visual coherence and its integration of structure. But when we really talk more profoundly about the life processes and trying to make inclusive space and really trying to make things that really enable people to feel like they have a connection to things, I really think that that's where we need to put our emphasis, particularly in terms of opening that up and opening up the possibilities of people really seeing this as an extension of the city. So I would really ask you guys in the next couple of weeks just to think a little bit about that. I think if you take some of these, where the project for me is strongest is like in these moments where you kind of hyper develop the resolution between the ground interface, the towers and so forth. It's clear that it extends into the building. It's not clear how that transforms the real opportunities creatively of utilizing that space. So I would say that would be a great contribution to discuss that.
Theo, I'm just going to add a little thing to what you said, because in the light of the last 2 weeks, one of the striking things for me about the presentation, as much as I adore the renderings at the end and the cinematics of it and all, it's shocking that everybody's walking in this landscape where you could considering all the kind of autonomous mobility devices that we have at the moment, and considering the kind of timeline. So I would really urge the group to think about a timeline. So meaning, if you were to start today with this project, by when do you think that it could be built? And how do you think that then we would be moving in a landscape like that? So that is, would we be walking is the question in such a vast landscape? So I think that it would be useful to the project and very much related to what Patrick was talking about, densifying a little bit the use of the ground and really thinking about how, because it's so fluid, it's so dynamic that it almost doesn't work together with just walking from one end to the other end for miles, considering that it would be built maybe, I don't know in how many years. So I think if you did this and you incorporated this in the visualizations, for me, it would be 10 times more convincing. So
I think it builds on, I think, some of the conversations that we had yesterday about phasing and time frame. But I think different from the project yesterday, which that was more about the sequential developments of large-scale urbanism. Here, I think it would be specifically with also some of the skill set that the team has to really demonstrate that the scales, that there's an acknowledgement of different scales and the opportunities that those scales kind of offer for different kind of programming. I mean, it's obviously not a programming first studio agenda, but I think in terms of being at a certain level now, also with being able to see this more from a gaming platform way of experiencing the spaces, I think this is at least my recommendation anyway for the studio and for the teams is to really now try to also take that one step further, and what Patrick is talking about in terms of social agency and interaction scenarios. I think at these scales that means something profoundly different. And I think an acknowledgement of that also in the presentations, I think would start to speak a little bit about the complexities of what that is and how in some ways that there is the opportunity to really see varied agencies in terms of some of these landscapes, which I think can connect to like the post-Olympic scenarios, some which were realized, let's say in London, and some which were promises. And I just think the more that we can somehow embed that knowledge, I think then the conversation becomes even more exciting in that sense. But I just feel like it's something that I'm just mentioning because obviously like the team has a certain skill set, but I don't want it to be interpreted, at least from my perspective, that the agenda is more like the Blade Runner of another level of different vision. I kind of want us to be quite sensitive to some of these larger kind of, especially in the social public domain, those kind of elements I think are so critical and important. And that is really the lifeblood of London with the squares and all of these other systems. So this would be introducing a different model. And I think that would be an interesting thing for the students also to at least be able to kind of tease out some of their thoughts on that. Maybe they haven't focused on that just because of the scope of working on a thesis, and at some moment in time, honestly, when production hits, and I think that happened with this team, it's great to have that precision to kind of finish the vision. But what I'm suggesting is that vision right now is kind of hermetically sealed in the power of the presentation. And I think at the same time, I would open it up, I think, to be much more inclusive at this stage, seeing this now, to be able to really not only problematize where success and where failure is, or where scale actually starts to lose its real kind of human attributes. I just think it's a good possibility. And I quite like the way that they worked to show the interiors of the building and a lot of the other things. So I think that they're capable of extending those demands, if that's okay.
I mean, what reminds me of, and you mentioned the Olympics, what was striking to us working on the Olympics is this idea of an Olympic overlay. So for the event itself, you have a whole set of ephemeral structures and canvases and graphics and lighting and furnishings that's this kind of overlay. And of course, when there should be spaces like this, and you can have a study of that, how you host a certain type of event, a larger event in a lot of these amphitheater-like spaces. I mean, if you look at our Dongdaemon's project in Seoul, there have been so many, whether if Seoul Fashion Show comes in, it's a total transformation with projections, with floods of elements and crowds. I mean, that could be, this project and some of those larger spaces invite that. You can look at online when you look at the Dongdaemon, or when we look at Galaxy, when we had kind of a big events there, suddenly there was this kind of transformation of the space nearly through the sheer bodies, and then with lighting, with other overlay ephemeral elements. So that would bring it maybe home, and
yeah, I think
that's one view or rendering one can still produce.
Yeah, because I think, like, just to go back to the scale of the intensification, I think if for those things to be really deliverable, it can't just diffuse itself across the whole development. I think there are intensifications. So I think for the students to actually also communicate what those things would be like. I mean, fashion show is one example, but the everyday aspects of a lot of the communities around, for example, from playgrounds to sporting facilities to all kinds of things, when we have these large landscapes, especially with the territorialization of some of the geometric elements, these eyelid shapes, I think it opens itself actually to think about how that can integrate a whole series of different things to really make the whole development into something that can engage at very different levels. And so my challenge, I guess, to the studio and to everything is, especially with the new tools that are being invested in, is to try to make those as part of the project more legible, and to invite the, one or two moments where we can really start to see what that is. Like, I know everything is in COVID mode, but the idea of human interfacing and coming together is super critical. And what that actually means, the kind of activities that take place, I think is a really interesting place to really look at the social responsibilities around these large-scale developments, and not to leave that to the imagination, but to hear some of the ideas of the students and yourselves working on it. So I think...
Yeah, I think I completely agree with you. And if I can add just a few comments, I mean, to me, this idea of the social interaction, and maybe also like the idea of triggering new ways of interfacing with the city, and of course with your neighbors. I think it was there in play, and I think it's there. I think we can see some very interesting glimpses of what this could be like. For instance, when this team in particular worked on these programmatic events within the tower, like these terraces, rooftops, or conditions on the podium, as you mentioned before, that are actually particular events that should trigger new ways of interfacing with the city, but also new ways of gathering and trigger social interaction, as you were mentioning. But I have to commend the team for the amount of work and also the final outcome, which is impressive. And in general, I mean, the resolution of the project and the efforts that the team made at all levels, starting from topology optimization, association with programmatic conditions, and environmental factors embedded into facade, but also some programmatic conditions within the towers, together with this urban proposal that not only makes a big effort to interface with the surrounding areas in a very interesting way, I have to say, carefully as well. It does also some interesting, let's say, it makes some interesting proposal in the way, for instance, it negotiates with the water and the river in a soft approach kind of way. So yeah, thank you very much for this presentation. I mean, it's impressive, really.
Just to quickly counter on some of these arguments, I think, because I agree that as I said before, that the ground remains still the most undefined and the scale is not clear. But I do prefer that in this case, they abandon in a way that layer of landscape articulation and density, but they flipped it and they really went for a vertical landscape condition within the towers, right? And I think that's where I appreciate that all of that richness that is not happening on the ground, it is happening as you go vertically. And those sort of spaces, richness, they will, especially in times like now where we cannot really be meandering around, that you could have that living within your tower, and these programs start happening as you go up, and the openness, the transparency, the terraces, even the shifting lifts. I think, I know that the reality is quite far reached, but I think that's also fun to play around and to really, as you were saying, that how can you move on the ground? I think that that's a way how you could move vertically to achieve these vertical landscapes that you can inhabit. So I think that's quite an exciting futuristic proposition that I commend that the team took that on. And that's why I don't mind so much that the ground is not so resolving that level of detail.
Yeah, I think, I mean, those points are clear, Paulo. I guess my point is that the ground may be addressing different communities. Because not everybody's living in those towers. I'm not going to be living in those towers. So I think it's not always an aspect of choice, but I think when it's such a development in a large part of the city, I think it's very important to be able to kind of engage the conversations with really different resolutions. I'm very mindful with the team's exploration as a research, but I think because they have achieved a certain level of things, it's more about foregrounding also how they communicate some of the intentions, because I think if it's left undeveloped in some sense, it's assumed sometimes in a way that starts to caricature things or starts to open up a discussion about things that I think the students have good intentions, and I think following it through with the same resolution, it's just something for people to think about.
Yeah, I mean, I definitely agree. I mean, I think there's a scope for developing one zone carefully looked at, maybe one for large public event, and then another one which gets more kind of intimate. I mean, let's say something like we saw earlier with Shaj's project, this kind of more human scale, small grain activated. That could be, it's just a fractal folding in perhaps of, or having a different morphology embedded in one of those lens spaces, still multi-level. I think it's worthwhile to add to this, and I agree that this is to counter. I mean, we have these fantastic atrium spaces and terraces and so on, and let's do one or two more ground activation views. I mean, it's been designed, just needs to be populated and maybe in one zone slightly more sub-articulated. I think I agree that this would, I mean, be important. So because some of these, of course, these urban water edges are nice, but we find them in many places. So a kind of a more dense ground articulation with filled with life, filled with people and diversity of opportunity would be very nice to see. And I don't think it will only add to the project, because at the moment we don't have special zones, special spots. We have the special tower cluster in the front, and we know what the structure is in terms of towers, in terms of back, the taller, more isolated tower in the back, etc. But we don't have an understanding of ordering and zoning out and differentiating that public space. So zooming into two spots would do a lot for making the project convincing.
So I just wanted to add 2 points. I agree with everything. I think it's really cool. I really like this future vision. I just wonder about the future vision of that location. You know, how much is that area going to change? And is that considered? Maybe everything is a skyrise around it, so it just seems less dystopian, and it seems more that buildings around rivers will have to take on these shapes in order to be able to withstand flooding in the future. So maybe it won't seem so sort of out of place. I do think that, of course, you'll zoom into these atriums and fill them in and color in people and plants, but I think you could give a lot of thought to how these buildings are generative to the environment around. You know, what are they doing apart from resisting nature and resisting flooding, and what are they giving back? And I think you have a really this beautiful prototype. If you could think about, you know, in terms of materiality design, you know, Theo mentioned a bit around culture. What are you going to add in there? What are you thinking about, you know, nature, the environment, renewable energy, you know, anything that can be generated by these structures that's giving back, that isn't just what we already know about, you know, solar power or whatever else. So I would think about that, and I would also think about the future of these city skylines and what you expect the edges of a river to look like, you know, in 20 years and 30 years. London is a great example, but of course there's others, because, you know, if you're going futuristic, then go all the way. Don't just make it using materials of today. You know, push the boundaries yourself, and also think about population. What will happen to the population of London in the next number of years? How many people are going to be around there? And so will you actually be a safe space where people flock to, or will you be something that people will no longer live near? And it's not just COVID, it's just, you know, as climate change takes place, and who knows what else. So I would push you to consider that also.
Yeah, I think that there's a lot of things that have been put on the table, and I think the continuation of the conversation from yesterday to today is obviously building up. With that, I'm mindful that we're on time, and we're going to take a break now for an hour, picking up the discussion for 3 more teams, starting at 4 o'clock England time. So with that, yeah, we hope, thank actually all of the guest critics who may not be joining us in the second session. It's been really an amazing conversation with many of you. But if you can join in the second session, obviously we would love that. But with that, I think we should also be a little bit civilized, have a quick coffee, lunch, and yeah, just want to thank everybody for participating and for engaging in the discussions. And we'll pick it up at 4 o'clock. Maybe we can log in 10 minutes before or 5 minutes before, just to be on time. Okay, thanks everybody. I appreciate it.
Really appreciate everyone for the comments.
Thank you.
Thank you.
Thank you.
their qualities. The world's largest place for exchange is currently located online, more specifically in digital game space, where virtual economics and communities are growing exponentially. Another main goal of our thesis is to ensure the generation of a vibrant community fabric that is well connected. People should have the ability to access most of their daily needs within a 15-minute walk or bike from home while being connected through a mix of land uses and building types.
The UK definition of SME is generally a small or medium-sized enterprise with fewer than 250 employees. The EU also defines an SME as a business with fewer than 250 employees, a turnover of less than 50 million euros, or a balance sheet of total less 43 million euros. Within this umbrella, there are three different categories: the medium-sized, small, and micro businesses. These categories are defined by turnover and number of employees that are fixed to 250. In the UK, there are 5.9 million SMEs, and in London alone, there's 1.1 million. SMEs make up around 99.3% of all businesses in the UK, so are enormously important to the economy. Millions of people work in SMEs. They are a key driver of economic and sustainable urban growth, and therefore also shape the community at large. Since neighborhood towns and cities are the combination of the development, renewal, and adaptation of a dialogue between these different stakeholders, we see that enhancing their collaboration with other actors, as essential in order to foster a truly participatory urban ecosystem. From Excel to SME, the workplace has truly shaped the way the city functions. Yeah. You?
Yeah, there's a bit delay. A part of Northwest London around King's Cross and Euston, which is the second most popular destination for the capital's SMEs. Various firms are attracted by the transport links to the rest of the UK and Europe. It can become a key location for many corporations, small medium enterprises, and startups as fast transportation hubs and research institutions all nearby. Part of the area next to Euston Station and along the railway has already been demolished for a future development, where we can propose a prototypical site for our project. Previous generations of master builders like Eduardo Catalano, Felix Candela, and Miquel Fissa pushed the boundaries of architectural form by designing from available materials and labor. Such constraints that help shape innovative and novel structural systems. Surface-based architecture have shown a design of non-prismatic geometries, which enhance user experience and at the same time is structurally effective through its use of curvature. Building complex geometries uses more than 400 million tons of materials a year, many of which are due to an overly complex formwork system that has an adverse impact on the environment. The expansion of the built environment due to the rapid growth of the urban population poses a challenge for construction development. With the advancements of form-finding method and digital fabrication, fabric and textile-based material offer a rapid deployment of construction, conserving more materials and energy and minimizing waste production. It has shown to allow for structural efficiency while maintaining possibilities for spatial diversity. So a variety of architectural vocabularies can be created through the design of applications of surface-based textile material to enrich spatial experience for users as our approach to a vibrant urbanism.
At the beginning of our study on urban gamification, we looked into agent-based modeling, where agents execute various behaviors based on a set of rules. In our case of participatory urban growth, citizens can be defined as social agency. Here we started to develop a prototypical setup for users' experience and user interface where people can become stakeholders of their own neighborhood, like selecting units to build urban massing or select to occupy a special unit. And this This is an agent-based strategy application for prototypical growth algorithm. The model starts to grow from a kickstarting of the production seed or the SME, then missing and number of population are being calculated regarding the relationship loop of supply and demand of public spaces, residential units, and retail units. Players have opinions on selecting where to place their units. We consider the variety of building topologies and typologies to have different effects on the number of population. Land value, construction price, and retail price are taken into account as constraints for player moves. Welcome to Interwoven, an online cyber-physical platform where different stakeholders can collaborate to build an entire neighborhood. This is a beginner guide that outlines the basic steps player will take. And the first step is choosing an avatar. And then additionally, they need to tell two basic personal information. They will give a name and put the initial budget they would like to start. Okay, and this step, some basic geospatial data about the area will be provided to assist the players in their area selection. These are locations of the trees, tube stations, stops, rail stations, railways, and bus stops, etc.
Communication between stakeholders and the communication between different stakeholders for us is an essential part in contributing to the game. So we have two different players. We have the contributors and we have two different stakeholders, the contributors and the players. The contributors are constituted of architects and urbanists and contractors. And on the other side, you have the players, which are mostly investors, developers, and citizens. The developers and investors and citizens evaluate and buy the assets that are created by the contributors. Sorry, just a second. There's a problem with my slideshow. Jan, can you launch yours?
Yeah. Just a second. Everyone can see, I guess. Okay. Yeah.
Okay, I think, wait, let me see if, okay. Can I try one more time? Sorry. I think now it's opened back up, sorry.
Okay, do you want to share? I'm stopping.
Yeah.
Okay.
Sorry about that, guys. Okay. Can you guys see it?
Yes, we're good, guys. Keep going.
Okay. So after gathering data on the site, the players spawn into the lobby, a vibrant community where both the contributors and players can learn about the neighborhood they are in and meet with one another to trade assets, which are sort of blueprint that contains a geometry that comes in different variation. So here you can see the player going into one of the SME type. And what happens is pretty much like they can sell and buy each one of them. And each one of them has like a sort of hype level, you know, like they're common, uncommon, legendary, et cetera, et cetera. And based on how much like pretty much an asset's being used or evaluated, it's becoming a lot more expensive. So really tracking here like the economic aspects. Yeah. So after the assets are bought, they are stored in the player's inventory, which helps generate different morphological options for each neighborhood block bought. So here the selection is typology and topology based and takes into consideration land use. Yeah, when for example, like a typology doesn't fit in a certain like massing, it wouldn't like allow it. Yeah, and once the assets are being selected and the player locks a position and pretty much it generates the grid for it, and the neighborhood experience here starts taking shape. Likewise, actually here we studied how a different player could create a differing neighborhood block with another set of building typologies at the adjacency of the previous, like video shown. So here, oh. So here, like different options. Helps create actually like how the player would experience the space and pretty much experience the neighborhood real time. And we simulated how like each one of these morphologies could actually take place step by step in the neighborhood. Like regardless of the grid, we saw it as an opportunity to kind of like track how each player would kind of like track each move that they would make.
Interurban users will be experiencing lots of different virtual activities. They can take a tour and discover the opportunities by walk or by bike. They can also attend seminars, workshops, lectures, and they can share their ideas and more. These shows the activities on the game that people gonna have. They can also create and monetize their own music venues, clubs, entertainment spaces, or any virtual experience. Also, Interurban is a good place for the people to find a nice accommodation, whether they are looking for a short-time apartment in London.
We develop fabric and textile-based design elements to be used as a catalog of architectural assets for the virtual and urban environment, and the one that can also work for the physical realization. Our study focuses on the tectonic of surface-based geometry and its procedural form finding of curvature to have the topology that is effective for both structural construction and spatial experience. Our research on design applications started from a study of minimal surface modeling, procedurally and mathematically, which we have seen a potential to produce a new spatial quality. Here we have different types of periodic minimal surfaces, and then we apply the logic of zero race lanes to simulate surfaces from defined boundary edges and anchor edges, and to see how they can be used as architectural elements. And in the making of prototype, we explore the technique of fabric formwork through topology study and digital simulation with anchor mesh attributes for tensile structure to carry casting weight. And we also explore the potential of digital fabrication with fabric forming parameters. To develop spatial and structural elements, we have defined different primitive types. Is it delay? Oh, okay. Different primitive types from warped surfaces, high-power geometries, arches, funnel, and catenoid minimal surface in different material uses. First is a fabric as a formwork system with an integration of tension cable net layer together to be able to carry concrete during the casting process and then later removed. And the structure is a full compression thin concrete surface. So this one with a curved high par with the cable net pattern imprinted in the surface when it is casted. So regarding the physical construction, we also consider the modeling of an effective topology that can be translated into patterning. Both are materials where the wide grid and the seam lines of fabric patches match each other. The cable net and fabric patches are spanned within the boundary edges supported by adjustable scaffolding. In the construction process, it can reduce the material waste that is typically involved in constructing concrete surfaces and improve formwork strategy, especially for doubly curved surface. Another fabrication technique is with tensile structure of curvilinear structural surfaces. The fabric patches, as seen with seam lines, are an integral part of the building's load-bearing structure, stretched between the connected perimeter edges. From different combination of our primitives, we can create a catalog of surfaces. When the small units merge and become a larger surface, the topology follows the minimal surface logic to connect the edges. In the assembling process, a combination of voxels first specifies spatial direction, then the patches are stitched together to form a surface and anchor on the edge. This is required for both the inner and outer surfaces. These are examples of the combination, a cantilever roof and a wide span shell like. For this vocabulary, they are suited to public space and open plan activities. So the tectonic from the use of fabric can be seen as in follow the structural logic. This is from an exterior view. And the next one is from the interior. So the seam lines are like part of the design aesthetic. And with the same technique, we also develop a residential units with 3 different unit types that have a diagonal growing direction, a single unit with a terrace, and a larger double unit. Aggregation is done by stacking and rotating the upper unit. Additionally, a duplex comes from a combination of unit A and B. The aggregation will define how the surfaces are merged. From the voxel-based aggregation, the perimeter beams can be defined to mark the boundary edges for the fabric surfaces, which then tension to define spatial volume, and other details elements are added. And this is how the fabric patches form minimal surface in the assembling process. Cluster of unit aggregations can be represented using voxel-based encoding, showing different residential types. It's a chunk of unit aggregations encoded from all 3 different types of voxel combinations.
Here we followed the similar logic. So based on the surface, we define like different interclastic shells and define different variations that were used in the game. We've had a similar approach also with the interclastic bolts, which you can see here in the renders. Yeah, and we tried different options for the for a different residential unit, like with the circulation core, 1-bedroom apartment, and see how exactly these can actually evolve into a composition. Likewise here. We also tried different fabrication technique. So this one, for example, flexible formwork is the one that was promoted by Miguel Fisac. And we try to study pretty much like each one of them like individually and see how we could use fabric as part of each process revolving around the construction of this neighborhood. Here we studied how, for example, we could create different facade panels and how we could, for example, like have each one of them made individually from fabric and then assembled. likewise here. Yeah, here are a couple of renders like showing kind of like the look and feel of this neighborhood. Yeah, and lastly, we'd like to add, like, you can become a playtester. Like the slides that you've seen actually were actually from the demo, like the interwoven demo. It was entirely developed on Unreal. You can join the Discord channel and become part of like the community pretty much. Thank you very much.
Okay, thanks, guys. We'll open that up to conversation now.
Maybe I can say something. I really really appreciate the kind of focus on the SMEs because it really is really very much like there is really a need for collective endeavor at the level of SMEs, because otherwise the big companies, the SMEs cannot survive and cannot do certain moves if they don't do it collectively. So I think it's a very well chosen stakeholder, if I may say. I also, for that kind of community, I really appreciate the kind of approach to having a fabrication system that is somehow more economic, if we may say, and that it's allowing for very different type of applications with a similar fabrication / construction process behind. So again, I think it's a very good match. And maybe, so there are many levels of the project that I really appreciate on how things seem to come together. Maybe what is less convincing from my perspective is the amount of open space that there is on this site compared to the amount of square footage that is actually occupiable and actually, if I may say, made economically productive. So there is where I don't see so much the alignment with the stakeholder, like who pays for the land work, for the groundwork, let's say. There is somehow a little bit of discrepancy, if you see, between the kind of approach that you have taken to the stakeholder and construction system in relation to the scale of the operation at the cityscape, if I may say. That's a comment that comes very obvious to me, and I would like to hear you speak about it.
So regarding the density, actually, what I could probably add to the conversation is the way we had this game set up was that pretty much like you have different morphological options that are presented to the user based on like an inventory. And that set of inventory like comes with different variations. We just outlined here one of the results. For sure, like it's less dense. And this is part of the evaluation criteria. Like one part of this outcome was it's less dense. But it's also the result of different players kind of collaborating with one another. As you can see, for example, in this video that's playing in the back, each plot of land has kind of like its own neighborhood identity. Like this own neighborhood block has kind of the opportunity to kind of create these sorts of adjacencies that can help each one correlate or like collaborate with one another. I don't know if that makes sense. Like from this perspective, yeah, sure. Like the renders here like don't look as dense, and maybe
it seems, let's say, from my perspective, to sustain your business case, because this is all about business case, I think, and I really appreciate the kind of gaming approach to this business case. Let's say small SMEs being able to join together collectively in defining a space that is determined for them. with a common construction system with variable possibilities and so on. But I think that to sustain your business case, you need way more square meters, way more, let's say, people to intervene in this. And therefore, you would have a lot more tensions, if I may say, between the different architectural components, between the different architectural resolutions. And so at the end, what now looks everything coherent and everything beautifully together and so on, almost like pavilions in the middle of a park, that might not be the case anymore if you want to make your business case work.
Yeah, actually, I agree. We should definitely take this in consideration.
If I can jump in a bit more on the resolution, because I think I agree with that business case, but I think just to focus the conversation a bit more, I totally respect the research part, and I think the coherency of understanding Dieste and Candela to make these shells and how they are formed. It's a bit disappointing when after all of your process and development fabrication that they do remain quite recognizable elements, right? I think they don't move as further away as we would have wanted, with the exception of the residential tower. I think those ones have a bit more playfulness and articulation using the material, fabric and stuff, but I think the pavilions, they don't really go beyond, right? I think, and I would have wanted to see, since this is beside the game about fabrication processes, I think it remains too much recognizable, right? And it doesn't become anything that we would want to see as fresh identity, as fresh way of understanding materials, composition, and then going back to the comment from Marta, then the density, because they end up being what they are, pavilions in the park, right? They don't really suit for densifying different scenarios or compositions of that, right? So those would be my sort of good moments and also critiques to the final resolution, yeah? But overall, I think it's very well put together and very well presented as well. Yeah?
Continuing a little bit, Martha and Paolo's comments, I really appreciate first I think there's a few contributions you're making intellectually here. Like the first one, I think, to kind of upend the whole economic model of the way the architecture industry works, I think is a really interesting one, where you provide a product, and it's actually something that could be owned by multiple people. So it challenges the idea that the architect operates in service industry and it almost makes it a product. It also talks about the IP and the fact that perhaps multiple users or clients could own a version of that, and they, rather than it being something that is done only in one place. I think there's a lot of interesting things there, and that obviously though ties into robotic production and the idea of how you can mass customize. And it wasn't so clear when you were demonstrating the economic model that those buildings could be customized. It looked like they were predefined and I could drop them into any plot. But ideally, I mean, if you leverage all the technology you've been and design methods you've been developing, each of those could be adjusted to each individual site. No, you could vary the number of units in the housing or the proportions of a pavilion and so forth. So I think that's one thing that didn't come across so clearly. When you get to what Paolo was talking about, when it gets to the fabrication, I thought the robot holding up the fabric so you could cast that minimal surface, that was pretty interesting and quite a beautiful piece. And I think it's at a scale that is more at the size of some feature in a prefabricated component, like a typical prefabricated parts up to the size of something that fits on a semi-trailer. When you get to the projects, I do see a lot of beautiful and interesting things going on in the minimal surfaces of the pavilions and in the housing. But I do agree with the kind of comments the others made that, and I think it comes down to the scale at which you're working. Like the fabrication was novel at a scale that's smaller than the individual part. And, that could have become things like skylights on the pavilions, window openings. And if you can start to vary the geometry through the robotic fabrication process at that scale, I think then that starts to really offer something that could be more customized and unique for each, say, of the housing units. That would be particularly important. How can they have windows that orientate to different solar orientations, take in different user requirements, to really offer something where the user becomes the key driver, not only as a consumer, but as someone who participates maybe in shaping their individual apartment, perhaps, or their individual plot of land. I think you're close, but that seems to be the missing link.
But what I think is interesting in the studio is what Rob mentions is that it's quite a business proposal. But on the other hand, I mean, this area is also located in central London, right? It's probably some of the costliest turf in the UK, rather exclusive. So the risk also of this approach is that you sort of start to make a distinction between what consists of the business proposal versus what is the architectural proposal here, right? And in that sense, the business proposal seems very far removed from reality in a sense, right? Because it's, well, it is some of the costliest ground in the world available, right? So kind of by definition, these shells are very, well, you can't build these vertically, right? So that, so because you've chosen to present it as such as a business case, it's also a bit tempting as a reviewer to sort of neglect some of the visual and architectural aspects, and to focus a little bit too much on the business aspects of that, right? On the economic aspects. So in a sense, it seems that, right, in terms of sorry to use a cooking cliche, but that you're sort of at the mise en place phase, right, where you are still learning the software tools, where you're still learning the visual language, but the amalgamation such that the ingredients become something novel. I don't think that you've arrived at this point. Otherwise, I mean, still there's such a quantity of knowledge and tooling and ideas to dissolve and to learn and come to terms with in a short while. Is that, also there are a lot of interesting aspects that you've presented, but it hasn't formed into something novel yet.
I do, though, enjoy the relationship between the, formulating a proposal that is based potentially in a new way of thinking about developing sort of not only the architecture and urbanism, but also sort of a culture, right? It's kind of moving the discipline kind of closer to contemporary culture in a literal sense, which as an idea I find fascinating, right? I think that's the goal of all of the contemporary designers out there. It's like, how do you do that? So I do appreciate that aspect of the project, tremendous amount. I just like the exhaustive nature of the range of material that they've shown, from the gaming, coding, scripting, it's like the entire gamut, which I also, as a student, it's fantastic to go through that process and a material investigation, etc. So there is a lot to this project, which I actually am very fascinated with. And if you take each component on its own merit, I find they're very interesting avenues, right? That one can continually explore. I love the candela, the shell structures and what that could produce, for example. I love the business aspects of it and the gaming aspects and how these cultures and communities can develop.
And, you know, I mean, so I commend this team in kind of trying to develop something that is potentially, you know, a way of materializing a moment in contemporary culture, you know. So I enjoy that aspect. I mean, I can hear the discussion. I think that for their development, the first question I have is like, how far up the process did Candela come, you know? And, you know, Fisac in Catalano. I mean, these are the guys that I think almost stunted the project a bit, right? They were fantastic when they were doing these things, and they were building these shells, and they would just build them out as far as they could until they collapse, and then they'd rebuild them, right? So, but there's a completely different sort of culture of making at that point in time and in history. So that, I mean, I have a feeling that that may have been the problem, because if you had gone and just studied kind of some of the video gaming and even the explanation through the voxelization of space and material, I mean, that's fascinating as an idea, right? So if you think about that and think that through, potentially to link that to a material sensibility, that is something that has to do with a contemporary version of Candela and these guys, what would it be? And I think that that's the link that I am, just speaking as a pure architect, you know, that's the link I'm missing. Because then the product looks very similar to things we've seen out of the DRL for a while, right? So, and I think that that's a missed opportunity, quite honestly, anyway, from my lens. So I find it ambitious and interesting. I'm also beginning to think to move around the question of, you know, the property is so expensive in London. Perhaps there are ways of opening up the financing a bit to not only the users and the way you've described it, but it could be a micro opportunity for a global way of producing wealth, right? For example, you can put in $10 as opposed to putting in thousands or millions, right? And for those $10, if you live in Moscow, for example, and you visit London, you have a gate pass, an entry for the day or whatever it is. So there are other ways of gaining that capital back, right? That are beyond what you have described, which will make it even more viable as an opportunity for this location in London. So anyway, I think that, you know, but I just enjoyed kind of, you know, sort of making sense of this project. And I enjoyed going through the entire sort of lineage and history, but it also made me dream a little bit. It made me think a lot about what the future could yield in regards to what you are contributing here. So I find it, as a thesis, it's very interesting. I just think the links could have been a little stronger between each aspect. That's all.
I mean, I want to come in and say, I mean, first of all, yes, beautiful project. There's a number of very beautiful building types. The mineral surface one, also the one with these kind of interesting diagonal ramps sliding up. The housing, this intricate nesting of volumes and then stretching the fabric across. And I do appreciate that you have the diversity of typologies and they're all tied together by the use of fabric. So there's always that anticlastic surface element, and it's translated, it remains fabric, it becomes stiff. We don't see enough about those variations actually, but you know, the cable net versus the fabric, etc. So I do like that as the catalog. I think there is no urbanism, and I wonder if you step back, why this is. I mean, this is a piece of collage city that you end up with the density is because the game wasn't played really. But in general, it makes me think with respect to this particular project of Shahjahan is what desires do we have with respect to an urban outcome, and how much can we if we desire more order and not just the kind of random assembly, it would a kind of market constrained game process deliver that. So that's difficult. One has to kind of, in a way, make an economic decision model to simulate that credibly. If you just toy around non-committally, Mises once said, when the socialists were trying to play market, he said that's just toy games. You play around, it doesn't cost you a thing. And you don't consider properly the weight of what you're doing. If that was simulated, you would get something else. But then you also would maybe have to then live with an outcome and learn to like it. But at the moment, urbanism here is particularly random. And I think if you then simulate it, I mean, there's far too much green, and the creek is far too dominant. And it's kind of, some of the other versions were urbanistically a little bit more convincing, but I guess, of course, they're all designed. All of these projects so far are just, they're not simulating a game process, they're just illustrating something. And that would be, for me, the next step in this. And my intuition and hope is that the rigor of the market process and the proper rationality, which is driven by, for instance, a land value gradient would become a density gradient probably. But then it would also have to be interspersed by it can't be monofunctional probably all the way through. And maybe the pavilion is only afforded by a larger structure which it attaches to, etc. So these principles need to be thought through, and my intuition is that we then would start to see something which has an intricate order we would find intuitively also more convincing than just this kind of, I would say, collage city, a toy ground, which is not convincing on the level of urbanism. But I think although the components I really think are very smart, and the strategy of using, as I said, fabric in various ways, you really have unity and difference at play in the pieces of the game.
Yeah, to come in on the back of Ali's and Patrick's comments, and I mean, we fully agree with the evaluation of the state of play. Let's say that this is the first year we wanted to try and explore various, not only technologies, but also, design expectations and outcomes that to sample them sufficiently before kind of taking a deeper dive into developing more detailed studies, etc. So in that sense, yeah, the urbanism, notwithstanding, I mean, it is clearly, as Martha suggested, maybe at best is the starting off point. Like it is like the first initial minimum set of buildings that is needed, and maybe we can kind of see like where, if you place these buildings, like what will happen 5 years from now, or things like that. So there's that aspect that can be explored further. And as Rob mentioned, that that there is something here about, or the motivation is to see digital fabrication and all of these maturing technologies, not only to make one-off buildings, but like to see large urban or sufficiently large urban districts constructed using such proven technologies. I mean, it's clearly material conserving and structurally effective, etc. And so why not actually attempt to describe a urban neighborhood that is built in this way. And so that's another thing that this team has put on the table, and also like the idea of financing it through fractional means, like through a online intentional community. So it's not a random community, but like a community that is kind of brought together through a synergy of or some commonality. Just the fact that they are on the similar platform, let's say, already makes them somewhat more similar than you might expect otherwise. So there are many aspects that the team has put forward and and worked on very sincerely, including considering the kind of user experiences or the user value of a digital environment or a cyber environment, and how that may potentially relate to the one that will be physically built, etc. So and so we agree completely with what Yele said, that for year one, like they are they put a lot of things on the table, and the final urbanism, like, or the proposed urbanism, is not convincing, but like the research and the ideas, particularly the spirited inquiry that they put into the research side has been very rewarding from our side to watch and evolve, and they definitely set up, like, for us the next year's agenda with far greater clarity than where we were at the beginning of this year, because like we definitely feel that, like, digital fabrication and is maturing rapidly, and so to see a mainstream use, we have to see not only the economic side of it, but also the the user value side of it. What does it offer from a user's perspective? What does it offer from an investor's perspective? And so on. So I think, like, I want to thank the students, particularly of this project, that they try to explore all of these differing aspects that and put them on the table, and as Ali said, like, it made it enjoyable for us to make sense of it. So it was in that sense intellectually rewarding, like maybe not in the final outcome, but like in the various things that they have suggested. Yeah.
So Ajay, can I add something to what you say? And maybe it's more of a suggestion for the future, but especially in the last 2 weeks of this team, because I don't want to be seen as like the one who's killing the project because of the business case. Actually, not at all. I am very fond of the project, and I want to follow up a little bit also on Ali's comments and some things I said before. To me, what would be really, really interesting here is that the game is actually the business case. So that, in fact, if you think, and here digital fabrication is the enabler of that game. So that, for example, if you think of, okay, if we are able to produce minimal surfaces in a very easy way, and we have a system of fabrication that allows us for all these variations, what is it that by minimal, what is it that we are reducing? So are we reducing assembly? Are we reducing kilos of material? Are we reducing, take the example of Philip Bloch, bringing a whole building formwork in a suitcase on a site, and what does that reduce in terms of cost? So you could play the game the other way around. It's like, what is digital fabrication enabling to save, so that what the money that is saved is actually invested in other parts of the urbanism, if you want, that traditionally can be seen as more expensive, right? So that at the end, and maybe as a community, you would say, until we reach that point, and we need that many players, that many savings, that many this, this project cannot go on, and is a way of stimulating that the community can grow, and is a way of stimulating that there is more involvement, etc. And there is where Ali's comment is very fun, is very perfect, because in fact you could even play in this game, contributing to the making of that place without necessarily being in it. So I think there is really a very interesting proposition. But I think that the game is not so much to populate the site, but to actually make the business case work. And then have the result and investigate it from an architectural perspective.
Yeah, we totally agree with what you're saying, and also what Ali suggested previous to that.
Martha, it's interesting, Martha, that there's this, I like your case, which you've made. I just want to go to the other extreme, right? You could also have, we did quite a lot of research in New York real estate and the real estate market in New York. And what was unbelievable to find was that, probably the most expensive real estate here is $15,000 a square foot, right? And it's probably the same in London in this location, what they're suggesting. But what's fascinating is that a grave costs 60,000 a square foot, right? So you could go the other way and say, okay, we're going to do this thing and it's above graveyard. Or it's got something else going on that it actually generates a lot of income. And then they could free up with the kind of the technologies and the explorations of how they would want to develop this project in a slightly more or in a freer way. So they could go either way, but both would work, is what I'm suggesting. That's all.
Yeah, absolutely. I mean, if these shapes and experiments have to go beyond pavilion, like we definitely think like these conversations have to be had, and we have to bring that into in some form of architectural discourse and grapple with it. Otherwise, like, yeah, we do think that, I mean, Martha mentioned Philippe Bloch's cable net, like both Alicia and I were part of it, like and so experience like several of these kind of pavilions, and we are totally convinced by the efficacies of digital fabrication, both materially, structurally, and in energy wise, etc. Like, so but if you have to start from pavilion and like want to imagine an urbanism like as unconvincing as the first attempt is, I think like that's why we came upon the kind of game mechanics as a way to consider economic rationalities, right? Like because we don't know how you might model it the other way, right? Like so
a different way, Sergey, maybe to consider that is because you guys are trying to do this kind of incremental populating kind of strategy. I think there has to be a kind of belief of the radicality of its extreme. It's it's radical urban form. In some sense, if the project is developing a platform, one could use an AI bot as a simulator to actually build up a strategy to version different ideas of what the city is. I mean, yesterday I was reminded by Albert in his talk about, strategies of building on existing strategies, like they added 12 stories to an existing tower, in the city of London, or for example, when he was working on the Bloomberg building, looking at the ground and looking at existing piling systems. So when we're playing the economy game, there has to be an agenda on the urban form with a certain kind of deliverable that says, for example, the ground is going to be liberated, or air rights has this kind of strategy. And I think beyond just production of like Fab Lab production, I think there has to be a coupling of dynamics of structures that allows that kind of freedom. Otherwise, we get into this kind of Poundberry strategy of populating in a very kind of cute way, smaller scale pavilions, which then the pressures of actually dealing with the economic models kind of fall through. So I think there has to be a kind of belief that actually it's not about incremental. It is about really somehow playing the game and versioning to be able to be exhaustive in this. And I think that sets up maybe something that you guys need to consider in the ways that you're looking at the processes of play. Because I think play should be ways that people can contribute, but it shouldn't be like buying a sneaker and customizing it like in terms of which color I want. So the kinds of decisions, the kinds of questions from a platform perspective should be tested, I think, with some radical
Yes,
kind of spatiality.
very much so. And like in phase one, they were closer to that. I think they got carried away with the kind of realism of some of these game engines, like forgetting about the game aspects of it. You know, the visual realism, and so.
Because my point is more about like how you set up the rules of the game and how that can creatively be something that can be participatory. Extending this kind of literal kind of gameplay into like thinking about how one can develop the rules of engagement. So I think like the more that can be conceptualized, and as we see these processes kind of unfold, I think the more opportunity that we can work on it more creatively, so that we're not recreating an expo site where we're kind of populating territories and have conventional ideas of what site actually is. And I think these are the kinds of questions that I think are there. I think some of the students in this particular group can start to problematize that as they write up their thesis in the next 2 weeks. But I think these are larger conversations that we have to, I think, really critically engage. But through, I would argue, a much more radical take on its spatialization and its, you know, advanced use of some of the simulation strategies that we're implementing.
That's right.
Welcome, Wolf.
Hi, guys.
Hi.
Good to have you join us.
Yeah, I was a little bit late, so I really missed the goal of this exercise. But what I appreciated is that you guys are moving in foreign fields, so to say, in the economic field and in the field of being realistic. That means you are moving into the field of the building industry. That's an advantage. It could be a disadvantage at all, because if you are going too far into the economic issue, then you have to make a business plan. Otherwise, you are a dilettante. Yeah, and it could be very interesting to have a business plan to build this whole exhibition area, I would say. Because what I'm really desperately missing is that the guys would have designed urban plan. I'm missing an urban concept. On one hand, because it looks like a garden city with no density, and I don't know how many people will live there. And this is very important for the business plan. And on the other hand, it's the variety of shape and forms, which look to me very old-fashioned, I have to say, because of the role model is Candela, and we are very far ahead of this kind of construction right now, or we could be very far ahead. And out of this, to make a new point of departure in city planning could be very interesting. So this is the first step of a development, which I would say it's very interesting, and I would like to see that on other schools as well.
Thank you, Wolf. I think we can leave the conversation for this project and move on to the next one, but I think it's a good conversation to kick off the second session. Thanks, guys.
Thank you.
Thank you.
When we get the next team's presentation up. Guys, which one of you needs to have their screen enabled?
Congo.
1 second, please.
No problem.
Okay. You're ready.
We should get rid of gravity. Guys, not radical gravity. We should get rid of gravity.
That's
Give
what
us
they're doing,
one.
actually.
Anyway, yeah, we're a radical gravity project team, and we're going to present our design research thesis. Every year, natural disasters kill around 90,000 people and affect close to 160 million people worldwide. They have an immediate impact on human lives and often result in the destruction of many buildings and basic community infrastructures, including bridges, roads, railways, and transmission towers. Natural disaster cause mass displacement. 31.5 million people are losing their homes after natural disasters every year. This number escalated in recent decades due to climate change and more people living in vulnerable and exposed areas, and therefore requires a global approach. However, the solutions to this global problem tend to be local, leaving people in danger from the countries that are unable to respond. They use land infrastructure that is often compromised after natural disasters. The available solutions for shelters are either quick to deploy but not durable, or the ones that can provide any longer-term accommodation, face transportation and assembly issues, require a professional workforce that is out of reach. The shelters tend to be fixed and finite, although the process of recovery is evolving and population needs and numbers are changing. Many of the settlements end up being standardized ghettos, which is not only depressive, it's dangerous for people that just went through trauma. The settlements are dependent on existing infrastructure for basic operation and many times are abandoned after use. We're aiming to address those problems, working on a global system that, however, corresponds to the location. Using air-based infrastructure that stays relatively unaffected after a disaster event, we are looking into controlling airdropping as a deployment method. Using the falling stage as a self-building stage, we attempt to deliver ready-to-use shelter settlements to people. Once on the ground, we believe that shelters need to have the embedded flexibility to deal with uncertainty and change. Through having an adaptive and generative system, we are aiming to produce diverse spaces for human well-being. We think that self-sustainability is an important part of the disaster relief architecture, providing people with at least their basic needs. And after the city's recovery, the shelters can still play an important role in its ecosystem. Here are the key features of our project. The overall timeline of the system starts from pre-deployment, which is decision-making stage. Then comes the deployment, our controlled airdropping, the construction stage. Land operation is the architectural part, and post-recovery is a speculation about its afterlife.
Pre-deployment. Our overall control system strategy is a combination of centralized and decentralized approaches depending on the stage. Prior to the deployment, it's important to have an approximate idea of the suitable settlement and alleviate highly choreographed process of dropping. Our approach is global, but we believe our settlements should respond to the context and the environment. After receiving the input data about the disaster, the system calculates the number of units and airplanes needed, analyzes the location, simulates the disaster possible spread, and decide where the safe zone is, then chooses the landing place and create an abstract plan of the settlement according to all these parameters, choosing which configuration of units and body plans we use for the further stage. Before starting our project, we conducted a research on civil aviation control systems and some of the recent developments dealing with its automation, like flight path planning using wind compensation logic. Based on that, we started to design our strategy to calculate the dropping point and overall flight. Dividing the wind into 3 categories: helper on the way to target, obstacle on the other direction, and in between, neither of those, we constructed a framework to test the calculation of the overall flight part. We started to simulate the navigation strategy by introducing coast-field map, so the units tried to follow the helper wind, avoid the obstacle wind, and with the third type, calculate their movement, adding wind compensation. Acquiring data from open sources from different altitudes, the direction and the strength of wind. We are able to calculate the approximate deployment point to minimize the need for maneuvering in real time.
Deployment. The part that starts from air dropping is divided by phases that are connected with altitudes. The units are tightly packed in an airdrop airplane. We calculated how many units we can fit in the big cargo airplane and designed super packs. In a radius of 3 kilometers of target area, the airplane releases them at around 23,000 feet. Then, while they are tightly packed and quite mobile, we started to think how to form a more context and flight-specific aggregation with minimal efforts. We started to simulate how, through simple local rule set based on rotation and small displacement, we can achieve different choreographies. So in a stage that comes after dropping, our units start to form specific body plans that optimized for the flight and correspond to the initial calculation based on the site parameters. The wind serves as a push force for rotation. The stage happens in between 15,000 feet to 12,000 feet.
Even after the calculation of the approximate flight path and the dropping point, we understand that our units need to have a certain capacity to maneuver because wind can change in real time. Due to the fact that we incline towards a more probabilistic model, optimizing the cost of shelters for mass deployment, we started to look into more passive strategies of control. We've discovered that the way the object meets fluid or air resistance can be actually the way to control its flight. So we started to work with fluid dynamics to understand the relationship between form and air resistance or drag. Then we realized that collective maneuvering will allow us to produce even simpler units, so we looked into how the form of the individual can manipulate overall aerodynamic form. How air viscosity or internal turbulence with the use of air pockets influence drag. During our exploration, we've discovered that different weight distribution affects the flight and its directionality. We decided to confirm this assumption by conducting a series of physical experiments attaching different weights to the surface in different ways and observe this behavior. The assumption proved to be right. Great. By introducing the surface porosity along the weight distribution, we observed how it affects both the time of flight and the displacement. We tested the angle of attack strategy. The way the form meets fluid is interrelated with how much rotation and drag is produced.
You are muted. After our free-for research, we realized that we built a certain intuition and we can start designing our units. The first prototype was based on a maple seed logic when auto-rotation was a strategy to decelerate and the directionality control was similar as helicopters have. But this prototype had serious problems with aggregation or building more complex and adaptive formations, which we consider very important. Our next prototype was very different and was based on parachute logic, but we started to look into using contracting airflow for space creation. The strategy for controlling the direction of free fall was inflating parts of specific units, changing the center of gravity of aggregation. However, this setup was very unstable in landing and the level of control was insufficient for us. The third prototype we designed combining more mechanical control with parachute logic. In option A, the contour was happening by contouring the shape of the parachute, similar way as in parafoils. In option B, by opening and closing the disc, the inflation inside contours directionality in aggregation lever. These prototypes were more controllable and stable comparing to previous ones, but didn't take full advantage of airdropping for space formation, and because of its rigid nature couldn't be tightly packed. We also realized that the surface area necessary for proper amount of drag has to be much bigger than it's needed for architectural purposes. That's how we came to the logic of multi-layering, and we started to test it by connecting different surfaces or layers in different ways. We examined this logic while dropping. These experiments showed us that the inner part has to be very optimized for the flow of the air through the hole to ensure the proper amount of drag. Based on these tests, we came up with fourth and fifth, our last prototype with multi-layers logic that combines flight requirements with architectural need for diverse spaces. By contouring the flow inside of pods in between layers, we can distribute drag that is opposite of weight, but can be easier achieved during the free fall. Our design path was very non-linear, but the latest prototype ended up having the most optimal level of control for our purposes and takes more advantage of dropping for actual space formation comparing to
So between 12,000 feet and approximately 5,000 feet, our units have the maneuvering stage where the main goal is to reach the desired destination. It happens by drag distribution in living pods, these cellular spaces in between two layers. But we believe our units should travel in smaller aggregations that we call body plans. This will allow us to achieve greater control having simpler entities, performing sophisticated tasks through their interaction and distribute work. In other words, some units can remain completely passive, optimizing the energy cost. We started to simulate what kind of body plans is the most optimized for the flight, having different braking thresholds in different wind conditions. And with more active wind zones, as shown in this simulation. We constructed pretty accurate simulation framework to try the logic of drag distribution on completely different body plan shapes. We ended up with the most optimized for maneuvering body plans and named them alphabetically. However, in case of the light wind, or without having considerable changes from the initial calculation, units can travel in bigger aggregations. After many trials with different drag distribution, purple dots are actuated living pods or source of additional drag. We came up with overall strategies for different types of wind. With helper wind, in the same direction as desired destination, the activated living pods pattern create a certain curvature that interacts with the wind, reaching the destination faster. With obstacle wind, we found the distribution that is on the contrary, minimizes it and has the minimum push. With in-between wind, we were able to produce a rotation behavior to the target. We also simulated how different connections affect the flight. And based on these tests, we made a catalog how different drag distribution can achieve different behaviors in our main body plans type, being in the same wind condition. All these tests we decided to reinforce with physical experiments. We started by having open holes only in two living pods, and it was relatively stable with minimal openings. Then we tried a simple, maybe restart. Then we tried a simple, not symmetrical drag distribution, and it proved to work. We actually saw the displacement. The third test happened with relatively strong wind and all holes opened. The result was a stable landing and a beautiful flight that people around enjoyed.
Before landing, the body plans aggregate according to our calculated parameters. The simulation shows how they attach through controlling the distribution of drag. The decisions with whom to aggregate, they take from the visual sensing and lasers for more precision. We tested some of the algorithms in ROS that can be used for this purpose. So using a Kinect-like sensor, units aggregate around 5,000 feet. We tested an unsupervised learning algorithm for land cover classification, distinguishing which locations are safe to land and analyzing the ground. Based on these parameters and GPS data, units make a decision to land. We conducted a series of aerodynamic tests for stability while landing and the impact force. Apart from technical execution of landing, we approach this stage as the one that actually results in space. Treating air as co-creator brings architecturally interesting possibility to discover new ways and new morphologies. We started to test a simple setup how to different weight patterns will result in architecture formation. Here, we introduced vertical force as well, which can be interpreted as drag. So closer to the ground between 4,000 to 1,000 feet, the units land after sensing the suitable location, locking the air inside of living pods and releasing anchors. Anchors take the impact force, saving the materials and also secure the settlement on land. The way the inflation or freezing the foam happens is by chemical reaction between citric acid, baking powder, and water. The pods that were actuated because of maneuvering reasons direct the architectural morphology on land. Here are the technical details that enable the unit to orient, interact, sense the environment, translate gravitational potential energy to electric, use the chemical inflation as a securing inflation strategy, wind inflation forming and maneuvering strategy, and showing the components for attaching to the other units and landing. In case something goes wrong, such as malfunction of specific units, wind change, or difficulty with landing in target location, the units should have inner protocols how to deal with these situations in the best possible way.
Land operation. The location where units have landed can differ from the one calculated by the system, so the units should bear a certain adaptation capacity. We tested how the agents pack and adjust themselves according to the given environment. A Pathfinder algorithm generates arteries between pre-calculated nodes and adjusts the existing network in its fittest form. After 990 consecutive iterations, now it's possible to observe a different number of units being aligned. The way the body plans land also could be different from the calculated one due to our more passive control strategy. So the units self-model and calculate the additional living pods actuation depending on number of neighbors, proximity to an artery, and its programmatic scale. From this topology of connections, the system is capable of constructing a network of points. It will become a foundation of the circulation network. The resulting distance is used as a function of fitness in an evolutionary algorithm that would try to optimize this length.
Connor?
Sorry. Different types of natural disasters may require different types of programs. But overall, we designed our settlement to have housing with water retention units, or where people can actually live, agriculture, and hospitals in cases where we have high numbers of wounded people. The program is distributed using evolutionary computing, being able to identify housing areas to the maximum, but keeping the circulation network according to the boundary conditions of each living pod. Illustrating it in an example of the settlement for 11,000 people and 850 families, on the left are the pods actuated by dropping, and on the right, additionally inflated ones with water harvesting units calculated. The small pods on the corner of each unit can be detached and joined with other units to create apartments for more people. the circulation plan, and possible programmatic division of the example of the settlement. For housing, the system calculates a variety of co-living spaces for different sizes of families. The pods can even create zones with small courtyards in between for larger families. Pod density distribution is customized according to environmental parameters such as landed state, program, terrain, climate, and circulation. The self-sufficiency of the settlement is something we consider is very important, especially after a natural disaster. We started to speculate how the rainwater flow can be guided by manipulating the outer layer surface. Different pods have different connections to outer layer. The ones in the middle are connected through arches, air beams that structurally hold the roof and can directly guide the surface above. The pods in the corner have absolutely no influence on the surface and can be moved to other places and join others. The ones in between, those influence the surface only if the size increases considerably. This is an example showing how by changing the size of pods, we can alter the outer layer surface. The settlement example showing how all these parameters guide the space. The choice to create minimal cellular spaces having sheds for gathering is also based on our research of psychological states of people after natural disasters. Most of them need to be around people, which they spend most of their time. However, a certain privacy is also required, even if the space is minimal. Population in sheltered settlements is not a constant. As a result, flexibility is essential for settlements to be able to adapt over time.
We understand that we need to address the need to adapt that can be achieved through changing the size of the living pods. Sorry. We started to try more passive strategies of stitching as a way to control the inflation. Sorry for the delay, it takes a bit time. We also examined stitching as the way to guide the surface. Then we came up with the idea that by combination of different materials with different rigidity and elasticity level, we can control the scale by only changing the inflation rate. Here are the catalogs of different elasticity patterns and resulted deformation after inflation. Combination of different materiality allowed all the aspects of the architecture to correspond to the physical requirements of adaptation by the interrelationship of outer layer and the pod. So we tried to introduce this logic of different materials combination to our living pods design. Combining rigid material, red, with elastic, blue, we are able to transform a deflated column into the biggest living pod where the ratio of space over material is in its maximum. The elasticity level can be also related to the transparency of materials, private, opaque, or windows like transparent one. Inflation rate, number, and the locations of actuated living pods can produce diverse spatial typologies. And this exemplifies how it adapts to the population changes by merging different sizes of pods. And the interior logic of the pod is based on the codification of inflation degrees, like giving different uses of each part based on the different behavior of living and showing different scales. To expand into the more diverse spatial typologies. And this is showing the components of the cellular pod with featuring the water harvesting net in the center. And this is showing the small size, medium again, and large size. All these changes in living pods affect the change of the surface. The water collection can be global for shared kitchens use and local for drinking. The curvature differs according to this differentiation. We also consider using folk catching nets to get the drinking water in dry areas.
Climate control is another strategy for self-sufficiency we're looking into. Because the source of our additional inflation is endothermic chemical reaction, which means absorbs heat from the atmosphere, we can change the inflation rate more often, getting sort of decentralized passive air conditioning system. For cold climate, the heat can be distributed from the shared kitchens that are placed strategically. Did the slide change?
I think, yes, it is changed.
Okay, am I here? So dealing with such, do you hear me well?
Yes.
Okay, good. Dealing with such complex issues such as disaster relief, architecture requires a holistic approach to the design, specifically thinking about the life cycle or a process rather than an object. Because usually the reconstruction of the city happens in phases and housing is rebuilt in the first phase, some of the former shelters can change the function to public buildings, providing the space for typologies that are missing. Other units can become objects of infrastructure, greenhouses, park pavilions, and sources of alternative energy and water in the city. We examined our system on 4 different scenarios with different types of natural disasters, different locations, geographies, numbers of people affected. The system calculates the number of units and superpacks for each case and airplanes for deployment. Then analyzes possible disaster spread to choose the safe location. This chosen area is analyzed from landing perspective. Choosing the most suitable place, the system spawns the units and calculates the approximate settlement plan according to terrain, climate, and translates it to our body plans language, optimized for the flight. During the flight, units transform from superpacks to body plans according to different wind conditions. Then the way the units landed is analyzed and additional inflation of units is calculated based on various parameters. Thank you.
This is our ending animation. We are very pleased to present our project. Thanks for listening.
Thank you.
Okay, guys, I don't think we need to hear the soundtrack again. So just
Yeah, we know.
we'll open it up for discussion.
I am a little bit reminded of the sentences on conceptual art by Solovit. He states that rational judgments repeat rational judgments, that irrational judgments lead to new experience, but especially that irrational thoughts should be followed absolutely and logically. And I think that is definitely what this project is putting forward. That you are succumbing yourself, that you are almost becoming a slave to the will of the concept at hand. And that's that pleasure that you take from pushing and developing it, and your ability and originality in making an idea really deep and profound and touching so many aspects. It's just very inspiring and intriguing to see that. So I absolutely enjoyed it. So thank you for that wonderful presentation.
Yeah, I would love to be in that bubble and see the next wave flying in.
I think it is a very poetic concept that I think we all appreciate, right? And I don't know about everyone, but I went through stages when I got very intrigued. That moment where I saw the unviability of this, but then at the end, I think when it all comes together, I became a believer that this could be a very viable and engaging principle, right? I think when you see at the end all the cells of the shells inflated and how it all comes together, I think it does reinforce, as Jelle was saying, that you became so driven to the idea that at the end, I think it comes together. And I think to the poetics and abstraction, I think it does make us engage and believe in it. So I think well done on that aspect, right? I think it does offer very original principles, right? Using gravity, using drag air to inflate and transform these living creatures as they come down, right, to the ground. I think that's very unique and very interesting to see. So I think just well done on all of those aspects. Yeah.
I agree with everything that has been said so far. Such a good idea, thorough idea, and very well executed and thought through at every level, right? I particularly like the, how you thought through the water. I thought that was particularly smart in terms of how the skin can begin to perform. The skin to me was the most interesting part, right? That in terms of both the materiality and also the aesthetic, but also the comfort, but also the pliability and intelligence of it, and looking at a new material in a way, I think is really interesting in terms of what is possible. And so all to say, I think the what you've set forth and launched in terms of the fabric is very smart. I mean, you can have now materials that are self-cleaning, right? I mean, that's an option in terms of what you can begin to, this intelligent material that can begin to do. It can also begin to, research is being done even at Penn, where it can sense the temperature on the inside to be able to see comfort, and also, and in today's day and age, be able to sort of clean bacteria out of, because all of these are the very, very difficult problems that the UNHCR faces, right, in deployments such as these. And so if the skin can do a number of things through these different layers, I think that all to say that it will enhance the thesis that you have set up. The possibilities are truly, truly good. The question I have about the deployment of it, and I know you went through a number of options of how this begins to flutter down and how it begins to come down. I just wondered if you had done a bit of research in terms of it not coming down with such a large surface area, but coming down in, you know, when they deploy emergency supplies, it's a really, really, really small packet that then deploys out. And I wonder if there might be some software or someone who is monitoring this, like a drone, that it comes down at its smallest possible capacity and then begin to build up as needed. That was one question, because it seemed like a lot of the time was spent in that surface area problem. And then the second question I had is, in these camps, another important part, you've looked at water, but cooking is really important. And how does one cook? How does one, you know, sustain that aspect to it is a question. And if you've thought about it in your sort of new city that arrives, that is, you know, part of the, you know, important part that goes into making this successful and having a cycle.
I find it a really inspirational project. I mean, I think it reminds me of two projects. One is a Buckminster Fuller seed pod deployment, where he kind of has a geodesic dome that self-erects after it's dropped out of the sky. And another is an artist, Graham Stevens, doing inflatables that self-inflate in the desert from temperature and pressure changes from day to night. That are both kind of interesting projects in their own right, but your project, I think, goes further in the sense that you've taken that on into a kind of clear problem space, and also shown how that it can become also a design opportunity, which I find really exciting. I think, touching on Hannah's question about the surface area, I understand the surface area is key to the project in a way. I think the project gets designed through skydiving formations in a way. And I think the video, even you take very clear angles into a final video that kind of indicate that too, where it's almost like skydiving teams letting go and grabbing onto each other. And I think that's actually, for me, I mean, the design of the individual pod was quite rigorous in the way you went from the physical prototyping, throwing things out the window, to then simulation environments. But where I think, although that's really interesting, I think where I get most excited is in this leveraging of the skydiving process to not only shape an individual unit, but to also determine some kind of clustering and organization of a community. And this is, you know, and your scenario is one where time is really critical, right? Like the idea that deployment quickly by air is obviously something. It won't work in every site, of course, or every scenario, but the idea that not only could you deploy something quickly, but it self-erects, but it also forms a variable number of spaces and some kind of almost like micro-urbanism. I think it's a really beautiful and challenging project. Well done.
I think it was.
Wolf, please. No, you go.
Okay, I think it's a great project. I'm really impressed, and I like the presentation very much, because mixing analog and digital medias, it was great. It was really impressive. I'm impressed. Congratulations.
I want to also say that
You know what I was wondering about? Yeah. No, you go. I come later.
Okay. I also want to say that I'm incredibly impressed about the level of following it, and the kind of amount of design and testing and simulations that you guys have put into this project is just unbelievable. So it's really incredible to see. I think maybe I would wish for the project same as we had in previous conversations, that the scenario of the project is comes into question a bit more. Because actually I think that you are proposing a completely radical new way of building and deploying structures on site, and there might be very, very different application scenarios. In some ways is a very contemporary how to say proposition, considering, for example, the space race and more. So I really think that you have very different scenarios in which that could be applicable, I would really like to have seen almost like all the opportunities that you see this project fitting into at the end, and not being you know, so much like married or attached to your original scenario, let's say, but because your investigation is almost more into the tectonic system and the aggregation system and the formation of this pod and so on. So it's almost like so contextless at some point, that it offers a lot of different possibilities for creating scenarios that will align with it. And I would appreciate that maybe in the last 2 weeks you can give it a little bit of thought on that aspect. Thank you.
I mean, from my perspective, what I appreciate is the architecture itself, even if you abstract from the delivery, which has its own fascination, of course, and there's been took a lot of emphasis, but I think it's a very seductive and beautifully crafted architecture. The thematics, I'm not sure if I fully grasp it all. It seems even the arches and columns are inflated, the floor is inflated. The question, I mean, it's an intricate one, and I love the bubbles and the clustering of bubbles in those shells. So I think I can imagine that to be a beautiful place and an interesting connection, dialectic between the privacy of the pod, although your shadow would always be visible, and then directly stepping out into a public, more public interstitial space. But I think it's beautiful and convincing, and it's important, I think, that it is also stands on its own in that respect. When it comes to the delivery, I'm just wondering if I mean what Hannah was saying, can you actually release such huge pieces? And that's one question I had. And can you really achieve the simultaneity of the formation with a single aircraft, or do you have to? And as Rob was talking about these kind of skydiver formations. How do you build the formation if you have from a sequential delivery into simultaneous arrival, if that's what you need? I mean, you're not for the whole village, but so I'm not sure if you've problematized that, but that's something which raises a kind of some question marks.
Since everybody is being so nice, can I say something a bit more brutal? So the quality of the computational approach, the graphics were jaw-dropping, phenomenal. But conversely, let's say the illustration that we see now being looped in the background, it really doesn't do it for me. In a sense, right? Is that, you know, I prefer to create this visualization that is now looping. You know, is that great literature doesn't spell everything out for you, right? And in a sense, this is like spelling out the project, right? It was already very, very clear in a sense from the graphics, and in a sense, this movie is a little bit substandard to the rest of the quality that was presented. On the other hand, it is refreshing. The norm is, in a sense, to see bad projects beautifully rendered. And here you see a beautiful project poorly rendered. So that is also refreshing. But in a sense, in terms of the storytelling, in terms of the music, not amazing, I would say, right? A bit too literal, while so much was appealing to our imagination. And I prefer that form.
I think if I could kind of come in here on a couple of things. I mean, I would agree with Yele in terms of the video, in terms of actually being a little bit too nostalgic in terms of the ways that it's communicating. But in terms of the project and the thesis, and really, I think, building on this idea of dropping as a self-actuation process, I think Rob talked about some of the projects, lineage, everything from Instant City, Drop City. There are all these kind of ideas. I think the idea that we set up in the studio was to look at land, sea, and air control systems, and then also to couple that with environmental aspects in some way. And I think in the context of this particular team, I think that they've been quite consistent about it. In terms of post-dropping, I think that this part of the project came late in terms of evaluating how it would be used in the scenarios. And I think to Martha's point, I think the scenario is very important because the need to actually have an instantaneous architecture, there's more demand on that. And the variability in the numbers has consequence in its organization. So what I quite like about the project's thought process is even that idea of the inexact organization and the phasing strategy that we've been talking in different forms with some of the other studios here is actually super critical. In terms of being able to self-assess. And that's where I think the feedback loop from the first to the second wave to the third wave, all of that stuff, I think is very important. So I think it's important to run this system all the way through. I agree that it's a deployable system, but I think the analytics of thinking about how this settlement urbanism is actually happening and evaluating is more critical than the interior renderings and for me at least, the interior seating organizations, because I think it doesn't take away from the power, but I think it's not a narrative project. I think that's not, for me, my intention or the students' intention, but the video at the end kind of makes a conversation about the qualities of the interior. I think that's important to communicate. So, but I also think like the numbers, the magnitude, and to think about the strategy of how those decisions are taking place. I think this particular scenario makes those demands, which I think is an important one. But I agree completely in terms of speculating on what the possibilities are. I just think that the novelty of dropping is not a novelty in itself. It's the ability of actually using some of these textiles, like I was mentioning, and looking at very kind of low cost, but really high performance ways of actually hybridizing those things. And being able to kind of use that in a way and in a scenario where, like in the other projects that you've seen in the studio, there's not a lot of attention to this, but there are ways of thinking about this for these scenarios at the moment, which I think would be helpful. I do recognize though that it's very prototypical, so I think a lot of other scenarios are there. But I think the coupling of population and the demand of duration and time and transformability has a very particular kind of sensitivity, which I think in some ways, I think really helps the research to be disciplined in a way. I also think the fact that these guys were throwing stuff, outside the window, making models like with squirrel suits and trying to see how they would actually perform is really important in terms of just like proof of concept, just to even test it, just to test assumptions. So I just want to kind of commend the team to do that, especially under the conditions that everybody is finding. But I think you see that the value of also just having the confidence to see where the differences are between simulation and between these, sometimes could be very crude at home, kind of in the kitchen models, the value that plays. So I think on a lot of levels, I think the team should be commended But I also think that I don't think you should be satisfied, if I can be honest. Like, for me, what's the most important part of these kind of projects is that they do have a life in some form outside of this presentation. Because the worst version of this is to kind of develop these kind of creative ideas and then at the same time not have the conviction to try to follow through in some form to continue to test and to explore that. So at least from my side, I think there is a necessity, I think, to radically change the way that we think about practice, and it should be more than just speculation and narrative, I guess, is my intention anyway. But I think the conversation is really positive, and I do think that there are a lot of things that haven't been designed. And I think that that exhaustive nature when you do design research projects is where you become obsessive, but you also become very open to listen to different points of view so that you can actually critically interrogate it. That's why I agree with Yele's comment for the video, because at the end of the day, it's not just about a space, an acute space. It's about this whole system and how deeply we can be able to somehow exhibit very different forms of control. So I think that inexact urbanism, all of those things, these are research subjects that we should be looking at. And then we'll get closer to, some of those larger desires of making instant cities and all of that, but maybe not with the consequences of some of those original visionary projects. And so thanks for the conversation, guys. If there's any last comment, if Ali has any thoughts.
I'm just thinking about, in these situations, if you look at refugee camps or any post-disaster scenarios, the major issues that crop up time after time are sanitation, security, and health, right?
Yeah.
So if you start integrating, like the project we saw yesterday with this project, right? I mean, it begins to have a viability in a funny way. But for me, for this project, I mean, I agree with you completely. I think conceptually it's really tight and it's come all the way and it's landed on the ground. But once it hits the ground, it has a whole nother level of potential and ways of thinking about some of these issues I raised, but about the life cycle of itself within the location that it's located in. So if you hit something in the north of Turkey, for example, versus in Australia, it would have a completely different dynamic, right? Depending on police control, or in Afghanistan, for example, right? It would have a completely different dynamic with regards to security and health and other issues. So I feel that it's a very strong project for where it's at, but it would be fantastic to see it continue through the latter stages of its actual implementation, because I would find that fascinating. Like, okay, so how do you actually, there are new technologies, et cetera, that you could bring in, and they've already thought of a few of these, self-cleaning, et cetera, that Hina mentioned, but also just literally like where do you wash yourself, right? And so with the way they're thinking, that's quite easy to do, but it would be really great to kind of see at what scale sort of those sorts of ritualistic concerns are met, right? And that's where I think it becomes real. So it's really strong. And I think just in the next 2 weeks, perhaps they can think about what the next steps would be, and less scenario-based, more reality, And I think that's where you're trying to push them, right, Theo, in a funny way. Conceptually, that's exactly the trajectory. I mean, you've had the two projects I've seen. One has been about a pandemic and healthcare, and the other one's about disaster relief. So what I love about the work in its totality is that it's connecting to real world problems, right? So for me, it would be fantastic to see that play out further. But it's a great project, guys. Don't let my comments take away from all the work you've done. It's really very fascinating.
Theo.
Yes, Wolf.
Yeah, thanks for inviting me, because these two projects I saw in the last 2 hours give me back optimism in architecture in a different level. So I can see that the schools are not running on a street with a dead end.
Exactly. Wolf, stay around for another one. You will be satisfied.
Again.
Further.
Is there another one?
There's one more. You have to see it. You'll not regret that.
Yeah. Okay. So
have a look. Have a look.
Because, but I have to leave in half an hour.
Yeah, exactly. That's enough. That's enough. Just have a look.
Okay. Yeah. Very good. Very good.
Perfect.
So it will increase my optimism. Patrick, will this third project increase my optimism?
I would believe. I think so.
Okay, great.
I think so.
Let's go ahead. Yeah.
We're always building up to the crescendo.
Let's swap up the teams. Let's get the next one up. And Wolf, thank you for the comment. It's generous.
Thanks, everyone.
Thank you for the comment.
You guys, can we get the last team up?
I hope my screen is visible.
Yeah, perfect.
Screen
Welcome
Go for it.
Welcome everyone to our research project Skyscape from Patrick Schumacher's studio. We are Du, Sue, Devansh, and I'm Luca. Changing climatic conditions are affecting lives ever more around the world. As a result, we are in desperate desire of urban development to be more sustainable and environmentally performant. We see environmental parameters as positive design drivers and believe that by enabling them, communities can have thriving lives and ensure future prosperity in the city. The research explores engineering and urban architectural methodologies to propose strategies reducing the impact of ecological issues through adaptive urban superstructures, which we commonly know as skyscrapers. The project culminates the research and findings into a pilot site, showcasing a multi-author and multiplicity of ecologies project with a strong unity. Next. Our research has three main areas. First, we look at natural systems. To address flooding, which becomes a normal part of our lives, we use riparian networks to blur the boundary of architecture and nature, making it a softer approach for our ground strategy, like the sponge city concept. Topology optimization is used for a controlled form-finding process in towers and helps us achieve structural and material efficiencies. The resulting exoskeletons can be used as signifiers and the program differentiation. Urban districts for us means resilience and protection by density, but also resilience through visual connectivity with atrias and voids in towers and facades as phenomenological devices, making navigation more easy and effortless. So in the first part, we looked at what urban developments lack a little bit, our first ideas that we want to address, like using connections in towers, working with rainwater in the ground, using environmental parameters like wind and solar, working with landscape strategies, and using a more connective landscape of towers and the ground. Also, in the towers, we want to have a more deepen in the facades by sky decks and voids and atrias, making visual connectivities and sky roofs. So here we come to our site. Our site is located in London, next to the City of London, across the River Thames, next to the Tower Bridge. Here we can see our site with the City of London and the shard framing it in the background. Our site has some nice features like the River Thames or Butler's Wharf. And it has great access, making it pedestrian friendly.
Seeing the presence and analysis, the dire needs of not just the neighborhood, but also this becoming a prototype model for the City of London, we directed our approach towards urban resiliency that imbibes various vital elements of prevention, absorption, and navigation system of water and its riparian boundaries. What are riparian boundaries? The edges between land and water that form an ecosystem of resiliency and utmost functionality, hence addressing the question if we could use nature and its forms to itself mitigate the problems attaching to floods. What if these edges between land and water were blurred, with rainstorms becoming more severe and frequent with every monsoon, particularly in the wake of climate change? Riparian strategies can provide much needed flood mediation, thereby an already existing urban flooding situation can be assessed and channelized in a 3-step program: prevent, absorb, and navigate. Building on this strategy, we attempt to give an urban ecosystem an alternative reality. Here is an example of how alternative reality of tomorrow's water vulnerable London could look like if we map the city not actually through streets and roads, but blocks, but instead of water pockets of low-lying areas that are interconnected with each other through a network of channels and integrated ecosystem. Now, assessing a site, particularly in terms of its vulnerability to flooding and sea level rise, which helped us create an algorithm of trading networks to rethink a new paradigm of resilient and water responsive landscape and architecture. Next series of development would formalize the base of our proposal. Our research and testings help us to achieve the structure of a riparian network, which could effortlessly help to direct water towards Thames, and also by giving some space for the water to be settled during sea level rise. The skeleton of the riparian network formed the base to create land masses that would be vital for our further research program. Structuring these land masses into 3 distinct zones, which are towers, low-rise structures, and water pavilions at the edge of the rivers. The 3 zones come together to form the base of our ecosystem and ground topography. The ribbon of land follows and interacts with the waterways. In summer, the circulatory network, which are also the catchment areas, become possible hotspots for community interaction and cultural sprawl. Main function of the riparian network design is to slow down the flow of water and has a high absorbent quality. In high tide level, the low-lying pockets become like sponges holding water, thereby changing the topography's physical appearance dynamically with the changing water level. In extreme weather conditions, these catchment areas would make the neighborhood less vulnerable to the inhabitants. Here's expressing a chronological timeline of the multi-diversity of these catchment areas that transforms itself phenomenologically as per the dynamism of the evolving and changing climate, as mentioned before, giving alternative realities to urban ecosystems that are resilient and playful. Moving on, the next stage was to make the ground more legible in terms of its spaces by activating the nodal and vital landscapes. Our logic was to achieve desired spatial qualities within the island morphology itself. We constructed a strategy where we could explore the essence of mounds. We identified certain locations to insert infrastructure which would complement the language of the riparian culture. Then we would categorize these locations as habitable nodes, which are unique in its configuration and experience. And it also looks at forming living, working, and leisure spaces for this urban quarter. This is the regenerated urban scape, which imbibes the values of riparian infrastructure and livable, adaptive, and dynamic shell structures. Each shell sits on individual islands by its unique programmatic feature, yet maintaining homogeneity across the site. In the zoom in, you can visualize how spaces are organized, keeping in mind a diversified horizontal experience. And a mixed use urban layout comprises day-to-day programmatic facilities for a coherent and satisfying usability. These smooth variations in the topography makes the character of the urban fabric subtle and more experiential and user responsive. A blend of different materiality across landscape makes the legibility of these shells vibrant and dynamic. The design achieves some valuable moments, such as these partial volumes opening up to the central space, making it a public plaza, which then bifurcates to these narrow public streets. We also envision our primary vision of converting the space according to the climatic condition. We realize that such a design feature helps us to also optimize its convex shale-like form as functional green spaces, and then how the plazas demonstrate multifunctionality during flooding events. Water pavilions at the edge of the site are one of our important features of the ground. During sea level rise, these fill up with water and making the site attractive for tourists and cultural engagement. The detailed attributes of the shell include intimate skylights and curtained glass openings and semi-open porches, which retain the sense of connection to the outside and enable seamless and organic circulation. The circulatory pattern keeps on substituting its accessibility with the flow of water into the site, emoting the seamless circulation and sense of unobstructed and endless spaces and volumes, generating a new typology of urban character that is dense yet resilient. This adaptive urban layout embraces various types of programmatic value which could be addressed within the design, such as shopping arcades, exhibition centers, restaurants, and here is an example of a museum.
So then we come to the massing of the towers. We started by creating a massing generator that gave us many options for spreading the towers. We then looked at the many different results and looked at the differentiation of the skyline it created. We didn't want to have a Renaissance one-axis view, but we wanted that it changes in character depending on different viewpoints, always with the surrounding city, like the Shard or the City of London in the background. Here we can see our massing ideas and how they would create different skylines based on different views. Next, we also looked at the sun hour analysis of the ground and wind simulation, not only to ensure the comfort on the ground, but also to differentiate the program in the shells of the ground and to have differentiation in the open spaces of the ground. So in the next slide, we can see these towers and the open spaces we wanted to create between them. Next, we can see how that would come together with the different readings, how they cluster together and break up. Then, for the towers, we looked at topology optimization as a design driver, making our structures efficient and optimized in material usage. So in topology optimization, we use load conditions and support conditions to drive the form. We started with small experiments to really understand this method, and then next scaled it up to see many varieties of creating such structures. Here are some first testings to create exo or endoskeletons.
So based on previous topology optimization tests, we got a various of structures which are categorized into 4 types. The first type is exoskeleton. Our aim is to achieve strong signification of the structure. So the structure flows only the exterior of the domain, which becomes the element of the facade. And here is the comparison of topology optimization result and the remodel result we translate. And then we did the structural calculation to validate our design and to optimize the beam size and thickness of the structure in a more efficient way. These are other towers in exoskeleton. Type B is sky deck. The aim is to get exterior relationship. It creates Sky platform for some special public programs. And here shows the load support condition and some details of the structure. And how the structure combined with slab configuration to get such deck. Type C is the twin tower. The aim is to interlink spaces. We mirror the structure unit and make some connections in between. The last type is void space. The aim is to create porosity in towers. So the structure also got from mirroring unit. Combined with the structure and domain, we can get such void space in between. The position of void is changing from different direction. These are other towers in void type. So here are all the towers we have from different height and size. After the studies and classifications of the structures, we are trying to explore towers on next level, which contains circulation, program distribution, facade design, and interior design to test different spatial systems on specific tower category. So first, we set different hierarchical circulation based on how structure flows inside the towers. And here we set 3 important zones of sky lobbies, sky garden, and the atrium void space, and how they align to these towers. Then we go to each tower's details. We have different design explorations of different towers. Here is how the program distribution and circulation in tower. So this tower has sky deck feature. Here's the thing which we attempt to have sky outdoor tennis court on deck. On next tower, these are the different levels of horizontal sections. And also the deck could be outdoor garden or drone helipad. The section of the center zone which shows both primary and secondary circulation. In next tower, we are also trying to insert secondary timber structure double head zones tower. The structure hold the loads of slabs and create multi-material spatial. Also in this one, which is sky lobby area in the tower, these are different social programs gathered. Also, the layers of timber, how it looks inside. Again, the circulation and programs. And in next slide, these are the typical plan of working studios, the residential studios, and also the plan of public activity center. They show the occupiable space on the and here we work on the
I will take over.
Can you hear me?
Our facade exploration.
Okay. Yeah, you can continue.
Okay. We first come to the ladybug sound exposure analysis, not only with single tower, but also with surrounding towers, so we know how this impacts the sound hours on the domain. Then we use it to drive the facade panelings of the tower. Our idea of facade is not only to work with mullions, but also with balcony systems which expand from slabs. And how that looks on tower, we have different strategies from north to south. Here we show different kinds of lures. For example, the horizontal shading elements, how it changes from north to south depending on different demand for sunlight. And also explode details of layers, the glass mullions, the sun shading louvers. And the view of sky garden area in void space combined with facade. Also with vertical louvers, how it changes phenomenologically. We associate environmental factor with the phenomenological act. The louver in the south is more closed and the north is more open. The exploded detail of facade layers. And also zoom in video. We have another attempt for the balcony system in this tower. The exploded detail of balcony connection, we are assuming to have solar panels on it. And then we come to further interior design.
For this twin tower, we try to design the interior and the connecting position of the two units. First, we did a preliminary functional partition and made a drop section. Then we refined the function into two parts, the library and the restaurant, and reconstructed the space according to the function by carving out voids or small edges. The visual and spatial communication between the library and the restaurant is created through the transparent void. So this integrated area not only connects the two units of the twin tower, but also transitions between the two different scales of office space. In a library space, the step bookshelves are designed to divide the space and some small semi-open platform that can rise to create a communication space. We also try to incorporate light into the structure to create the atmosphere needed for a bar. Void space also opens up more space design positions for us. Different public spaces are interspersed in the office tower. After initial planning, we refine the functions of these areas. The lobby on the first floor serves as the entrance of the tower, transitioning from the temporary meeting area to the office area. The lecture hall consists of the stage and the auditorium, and the upper floor also has a space for occasional events such as exhibitions. In the conference room space, two suspended meeting spaces become the centerpiece. Two circulations for the elevators meet in the HM, then we deepen the design of this part of space. Due to the distribution of void spaces, the meeting space remains transparent from lobby, shared working space, meeting room to cafeteria. In the design of the public space, we try to create a variety of spaces without destroying the integrity of the exoskeleton and facade. A floating conference room provides a bird's eye view from the lower level to the co-working space and reception. In the performance and lecture hall, structure and lighting are also a part of the stage composition. The structure can also be used as the frame to highlight the stage. The light strips surrounding the structure and floor step provides guidance and create the atmosphere when the night falls and the show is going on. Here is the rendering of the cafeteria. We also experimented with the way towers were connected. First is the topology optimization of the podium, which applies support at the bottom of the tower and the bridge between towers. Here is an example of how bridge connects two towers. Bridge uses the same structure and facade language as towers. In addition to connecting the floors of two towers, the bridge can also be a gathering center where public events take place. We also try to connect more than two towers with different types of bridges. These three towers are relatively close together and have the same skeletal structure. Then a part of tower structure is applied to the bridge structure to complete a group of connected towers. These two bridges also become the extension and transition of the functions of the three towers. One of the towers serves as the nursing center, providing the function of nursing rooms and vertical HM garden. In this group of residential towers, public circulation runs through the vertical HM garden, while private circulation serves people living in the nursing room. In another two layers bridge space, the sports and spa functions will be extended across the bridge and continue the greening of the HM garden. The Sky Garden restaurant on the top floor also extends the greenery to the exterior of the tower's top. In this tower group connected by bridges, the facade also becomes part of the visual connection. Because of the distance, only three towers are connected by bridges. A fourth tower farther away from them is connected by the facade on the same phenomenological system. Two towers with height above 300 meters use three-layer circulation, and in this group of office towers, the main public space consists of bridge layers and interior HMs shaped by the structure. In the bridge, in addition to retaining one floor as passageway, the other two floors are used as swimming pool and diving platform. The sky platform can be seen from the restaurant and bar above the bridge layer. This is an attempt to connect the tower with podium and platform. The platform forms a ring in the same level of three towers, while the podium provides access to a tower in different directions in a large area of open spaces. So this group has platform connections at two height levels. The platform has also become an extension of the HM of the tower, and public circulations will follow the HM from the bottom of the podium to the top of the tower. We also have the idea of occupying the structure itself. Here is the imagination of the sky platform.
The next series of design exploration is taking you through one of the most vital part of our design proposal, where the elements of vertical habitat meet the ecosystem of ground realities. The design is not just responsive to resiliency, but also the way a user experiences the built environment. Dividing these experiences into typologies are shell structures that form the different junctions between the towers above and the ground landscapes. Here we see an optimized shell structure, which becomes a frame for the stadium and also merged in with the tower structural language. As we go inside the structure, we see various levels of interaction. One is the lobby space, second is the sky deck and sky lounges, where people could experience their favorite sport from 20 floors above. A walkthrough along the lobby space, which can also serve as ticket counter and other services. Another shell type is that of a strip mall that invites arenas of vanilla and anchor shops and an urban flea market. Layers of this shell explain the interdependency of the ground with the shell and that of the tower. The mushroom columns are a water harvesting strategy that is used as a physical feature of urban sustainability. Next type is where towers sit in flat shells and in return also creating a podium level for green spaces. The diagram is a preset of understanding how a typical topology of the ground and the shell and the tower function together. The relation between the landscape and the shell design levels up the coherent factor. Next design condition is where the towers meet and their immediate context, and also supported by flat and semi-flat landscapes that create an interesting network of foreground and experiential grounds for the tower. Curbing the landscape topography in resonance to the tower structural features. Visuals showing the circulatory path and experiences towards the tower. Moving on, formalizing the detail of the shell connection as a direct response to its tower placement and form, along with its vital circulatory medium. Different layers of structural system coming together to form a well-organized tectonic configuration. This gradual sloping green roof interconnected with the tower, making the usability more three-dimensional. This type showcases stacked podium and slab levels, which takes the shape of the islands and the shells, along with the striking features in the bridge and habitable step roof gardens along give an opportunity for different domain of cultural and recreational activities for the inhabitants. The exploded diagram explores spatial organization of a shopping center along with a central lobby atrium, which connects to the tower above. Finally, the last interactive condition is about morphing the clusters as a unified ground connection where, example, the louvers of the towers convert into a canopy or a shell at the ground level. Here we see how the shells are sculpted in a way that it makes way for the structural columns to pass through, which also in return execute as a skylight for such institutional spaces underneath. Different layers of complexities come together, forming a unique habitable shell layout, making the internal experience and horizontal connectivity seamless to the inside and outside. Concluding the design proposal is our vision of the big picture of the eco-habitat where every element of our research comes together to a diverse yet homogeneous system. The master plan demonstrates organic forms which maintains a design vocabulary impelled by principles of correlations, phenomenology, climate responsive, and people-centric approach. The placement and configuration of our towers makes it possible at certain moments to make human eye perspective seamless to visualize the context and the site. In this case, we frame the shard and the walkie-talkie tower within our urban scape. The detailed characters of the towers are derived from a conscious thought of dynamism through material, facades, volumes, and its spaces, which can be identified differently from various contextual viewpoints. This organic nature of our design intention responds to varying requirements of function, cultivating a diversity of buildings at a human scale that establishes a sense of community. The public plazas act as transitional spaces between shells and towers, which takes in account the flamboyance of the uninterrupted circulation, creating multiple nodes and scales of bifurcation. The physical fabric of the proposal frames views for the users of the community to give a powerful, lively, and a bold impression of the iconic architectural and landscape style. Some views from the bridging points to towers, which are avenues for leisure and lifestyle. The interior spaces of large semi-public and public arenas like this theater have a constant visual connectivity with the skyline of our urban quarter. Through our research and detailed understanding of lives, lifestyle, future, and response of climate and resiliency of urban city like London, we anticipate that an approach like this that intends to be responsive, adaptive, and narrates a story of not just architecture and landscape, but also envisions a horizon of a new lifestyle, making the current neighborhood less vulnerable and more progressive towards the unpredictable future.
Here we come to a video showing our proposal with the City of London, and with the context of the other projects, of the other groups we saw yesterday and today, making it a coherent district, and here how it would look like from different viewpoints, and how it clusters up together, opens up new volumes or voids and views from the different sides, from north, west, around the city. Also these special moments of going through the clusters and how the facade changes from completely open on one side to having louvers that react to the sun on the other side, making it closed. And how the louvers change from north to south always, having a different impression of the district, whether you are south, east, west, or north. And with that, we would like to thank all our DRL family, our tutors, professors, our phase 1 helpers, and of course, AKT for their incredible supports. And with that, we like to thank you for your attention and welcome your comments. Thank you.
Thank you.
This will just play along now.
Yeah, we can open discussion.
Patrick, yeah, I stayed. I had to leave 15 minutes ago, but I stayed because it was so interesting. As you know, I like the towers very much. And what your towers, Patrick, your towers, and the new towers, I saw great. But for the guys who designed this kind of towers, I would really love to see the wind diagram, because playing tennis on the 19th level, not concerning the sky wind falling down. I would love to play tennis there. I want to see tennis players there. The wind diagram for the towers would be very interesting. Yeah, the gaps in between. I think this is enormous wind power going through, and how to pretend that would be a great solution and a great addition to the structure you guys are proposing. So great. Optimism is rising. I like that. Congratulations, Patrick, and to your students.
Thanks a lot, Wolf.
Thank you very much.
It's really
spirit.
That. Yeah.
Wolf, you're in a good mood today. You can't just run away like that. You're in a good mood. I've never seen you give 3 good reviews.
I could criticize that these towers look the same all the way.
There you go. Now the wolf is coming out.
Yeah.
Keep going. Come on, Wolf.
I love it. I love it.
You know this.
Of illustrating the future fairy tales. It's great. Congratulations.
Thank you. Thank you so much.
I'm sorry that you guys couldn't teach in Vienna anymore. It would be very helpful to get this provincial city I'm living here in a higher level, architectural level. No,
I know. I mean, Vienna contributed to this. What we're doing here, there was a lot of 15 years of synergy.
Yeah. No, it's nice. I want to see cities like that. Guys, congratulations. You did a great job.
Thank you so much.
Thank you so much.
Thank you.
Thank you, Wolf.
Concerning the wind and the sun, it's always good. It's always good. This is a new perspective for designing, yeah? To integrate climate things. By the way, I don't think that the south elevations are enough to keep us from getting Kentucky Fried Chicken inside the buildings in the next couple of years. You know, when we designed in Cheddar, we had a proposal. We had to do a proposal for a city district next to Old Cheddar. So we studied Old Cheddar very carefully. How they designed the spaces, and how they designed the climate things, and translated into contemporary elements. The client said, great project, but I have to say, my people now want to live in 300 meter high glassy towers because they want to see the desert and the ocean. And I said, okay, glass covered towers, okay. What will you do in 30 years when you don't have energy anymore? Then the towers will be Kentucky Fried Chicken towers. And they said, who cares about what will happen in 30 years? I sell it now. It's a good argument, huh? Okay. And congrats for your design. I got just an email. You got to build these 2 towers with the skirt blowing up by the wind. I really love it.
Thank you again.
Thank you.
Thanks for inviting me, Theo.
No problem.
It was great. Your school must be a great school. Ciao. Bye.
Ciao, ciao, ciao. Thanks a lot, Wolf.
Thank you so much, Wolf.
Should I just continue with a few points that Wolf started touching on? Yeah. I think first of all, I think it's same congratulations. I think the work it's really outstanding, and the depth and resolution of all of this is really great. I think if I can be a bit more precise and picky in some aspects, right? I think, and a bit comparing with the previous team from your studio, Patrick. I think as I see much more here, the sort of the ambition and obsession to design much more every single aspect of scale. The ground is much more defined and rich. You know, I think that has much more definition. I think that's a very valid and very beautiful resolution, right? But I think one aspect that I feel that there was not enough obsession on it was something that Wolf picked on. There were no parameters that would make this much more refined, right? I think the previous team really went, and I commented on the optimizing the structure and how that made it much more legible, more elegant, the features. I think in this project, I find that it still looks a bit more willful, the skeleton in some areas, right? I think that sort of rigor, or even the thicknesses of the structure as they go up, how they become more filigree. I think the intentions are there, but they don't come out as strong, because I understand them then it was driven by designing much fully all the other elements, right? And I think when this one succeeds further is that there is a much more coherent integration with the landing of the towers, with the relation with how it touches the ground, how sometimes it opens up and anchors and then creates some programs. And then similar features that are very successful, right? How the playfulness of the double and triple and 10 levels height that allow for this openness of the tower, you know, these different programmatic conditions. I think those are all very, very interesting, the typologies as well. I just feel, even though when you see it fully, I think even the modeling conditions look a bit rougher, because there was not that sort of obsession of making this optimized fully, understanding much more the parameters. But I understand that this is part of the process, but this moment is beautiful, right? When you can really see through
it's definitely here what you see is there's some of the ruggedness of the topology optimization, and also then a deliberate differentiation of, you know, allowing slabs to come through in one point, balconies, various types of louvers, and sometimes the structure isn't is partly building into the slabs. So that there's more of that. That's quite deliberate partly, but also there's multiple authors here. So you can see that some of the towers are very streamlined and elegant. Some of them remain very rugged and more nearly amorphous, which also is partly to do with these systems. Once you set up an initial asymmetry, for instance, if the bridge is hitting not concentric or is on a slope, it triggers off a series of irregularities, and they're allowed to persist here more. This is teasing out, you know, and to some extent, yes, it's sometimes a more rugged aesthetic, but not everywhere.
No, I agree, but I think it comes through, right? I think all the concept and principle, they do come through, and I think that's where the richness comes and makes it very coherent as a final resolution, right? So well done.
I think for me the thing would be to, as an interim stage, to take one of those more let's say less streamlined and less symmetrized towers, and then work them through so that they become reach another level of elegance, which is even beyond the easier elegance. So that, but it's of course not at that stage always visible.
I agree. I think it needs that sort of final comeback analysis to make this really, this is the one, we really optimize it, we really make it pristine, right? But I think it shows that there is still that next level to be developed, so it's good.
Just continuing from Paolo, I was very impressed by the project and a little overwhelmed with how much work you guys have done. Like it's as if you're, I mean, a full office producing this thing almost, you know, like very impressive. Both in terms of the design and the thinking behind it, but also the productivity, you know, like you've literally designed a huge section of city here. I think the landscape and its thinking about the Thames Gateway water levels rising is really considered and beautiful, and makes for a really interesting kind of groundscape, and also a nice opportunity to see a little bit more of a kind of pedestrian relationship to the tower typology in an urban setting. So I think that's a really good contribution there. The towers as well, there's some amazing work there and beautiful design in some of the towers and some of the interiors, like the library and a couple of these interiors with the stairs were really beautiful and well-crafted spaces. I think where I question how we look at this and what we do with it, it's similar to kind of Paolo's question. I think or comment, it's like we have a lot of different designs here, and because you've designed so many, we haven't really got the opportunity to dive into some of them and talk about them. And there's a few different ones here. I thought all the detailed explorations you did were fantastic and really beautifully done. In terms of when we're looking kind of at part of the building. When we look at the overall building, some of them are symmetrical, more symmetrical than others. Some of them have thin frames, some of them have thicker frames, or the variability of the framing. And I guess there's a question there of both the aesthetic and the practical criteria. It'd be nice to be able to pull out, you know, a few of the real extremes that are different from each other, and just do a comparative analysis. Which one has a kind of better floor area ratio from a development point of view, which has, you know, kind of better structural and spatial considerations. Like, I think some of the most interesting structural ones, are they ones that provide more interesting spatial opportunities, or is it the other way around? I think there's a few things that you can interrogate just by pulling apart what you've done. I mean, I'm personally more in favor of some of the ones with the thinner framing, and where the framing kind of turns to the inside, and you use that in some of your spaces quite effectively. But yeah, really, really beautiful work. I would be interested to know actually how this compares to the density of something like the Docklands, you know, or the Isle of Dogs. But great.
I agree with Rob. Everything that has been said so far. What an incredible amount of output. You know, well done in terms of just your relentless, you know, for every tower you figured out the structure, you figured out the envelope for every single different variation, and I'm very impressed by that that goal or that you were trying to reach that you have. I think it's really good. I'm blown away by the landscape. I really am. I find it to be beautifully. I enjoyed listening to the thesis of how it was generated with the water connections and just how it's manifested itself. I just find it really stunning. And the moments that, you know, when you're coming in, and my favorite moments are in the landscape where you've got 3 to 4 different layers that begin to come through, and that is and how in some of the towers or one tower, it looks as if the landscape has derived the interiority of the tower. I wish that could have continued more, maybe in some of them, because I found myself wanting to connect this landscape and the towers more. There's a little bit of a separation between the design of the towers and how they manifest themselves, and then the aesthetic and qualities of the landscape and how those manifest themselves. And all to say that I would just be looking for ways in which one could close that gap a little bit. You've tried it in some where there's that one interior where it looks like you're in a landscape and those qualities are there, but how could one introduce, I find myself asking, how can one introduce more such moments? The second thing is in the beginning of your presentation, I was very excited, especially looking at the project that we saw yesterday, that here there might be some mid-density, not all towers, so that there's landscape and then there are towers. But what about in between, you know, the 12-story, the 15-story, and that's where the site comes to mind. So couldn't, for example, on the edge or the periphery of your site, could some of these towers have been influenced by the landscape, that you would have had these 12, 15, 18 stories, and then there would have been more of a clustering of these towers where the height would have been in sort of these other intense moments, which would have made it more important. These are some of the things that I leave with you as a thought of, you know, maybe where this could go next. But all in all, really well done.
Thank you.
Yeah, I concur with those sorts of comments. Look, I think that this project has kind of a maniacal nature, which is great. You know, they went through and really tried to kind of go in and figure out all the layers and how they come together, which I found very interesting. I think when the two towers begin to meet, I think that's an interesting problem, Patrick, you raised, which is, you know, if it's asymmetrical, then it produces a complete effect on both towers, right? Eventually. For me, I just want to comment on the overall thing. It's, you know, it seems that what becomes important when you do multiple towers is the space between the towers is as important as the space within the towers. And that's where I feel that these towers have not, I mean, I think that that's the next step. It's kind of really thinking about the relationship at an urban scale would be the relationship between things as opposed to just what those things are. And if that's achieved, I think the choreography, you know, when you're flying through this last animation, it would be much more curated with regards to the sensibility or the, let's call it the aesthetic that each project is trying to generate. And I think that those conditions would then trickle down and affect how they meet the ground plane, et cetera, right? So the potential of the in-between space, I find fascinating. But when you get to, say, two towers that are not elegant, that are next to each other, they look even worse next to each other, you know, or the structure is somehow not I'm not going to argue for correlation, but I'm just saying if they're just not positioned in the correct way or the correct density next to the tower next to it, then it kind of reduces the effect of, say, multiple towers, right? And I think that you're getting those. So when you get kind of towers, so when the towers are bundled, right, it's the space in between that you really look at, and it's, or the edges of the outside. And so each tower may be really refined on its own, but when they get put together and clustered, I think that's the challenge at an urban scale. What the view is, how you look through these, what kind of forms and spaces do they create, etc. So you can definitely see spaces that are better and spaces that are worse when you're flying through this animation. And so that's kind of where I think your project can take on another step, right? But I really do find the maniacal nature of these students fantastic. So congratulations, guys. I'm fascinated. I mean, I agree with Rob, some of the interiors, particularly in the office spaces, I think your conference rooms you were talking about, really spectacular, right? So the exoskeleton technique, I think, at a certain point, you have to, I think through its fullest potential and where it's really good and where it's not so good, because or the endoskeleton, either one of these strategies. And when I think of Miami, it's kind of the most elegant tower in the Miami skyline by 100-fold. So the question of control and relationship to kind of the interiority and the functioning is so tight. And I think that that's also kind of some of the considerations that are brought into reality, maybe also partially grounding these projects in a more comprehensive way, maybe more challenging, but also better in the refinement of all your proposals for each one of these towers, and then multiple towers, and then for the urban condition itself. But look, this is a lifelong pursuit, and you started in an incredibly strong way. So I'd encourage you to follow through and continue pursuing the goal that Patrick has set up for you.
Thank you. Yeah.
And I think this guy, Luca, you're going to be very successful, man. I can tell you're going to.
I have to.
You're going to be a manager. You're going to be a project manager. You've got to be careful.
Thank you, but I have to.
But I have a feeling you're going to end up being a project manager.
Yeah. So. Thank you, but I have to give the ball to Devansh. He designed most of the spaces you really loved. He was the main driver with the interior.
Told you, you're the manager, though. You're going to do better than him in life.
This is all a bit getting all a bit sweet. Let me see if I can throw in some acidic comments, just for a variance of flavor. But I really love the sort of grandiose scale of the studio, right? Its boldness and its confidence. That's great. So my question is, or comment is more revolving around typology and topology. So it seems really, I find sort of the initial phase of the topology optimization is a little bit crude in a sense, right? It's a very rapid evolving field, and in comparison to the state of the art, you're behind the curve quite a bit. What I mean by that is that, for instance, if you look at some of the plants, the members, the sections, and these are gigantic structures, right? I mean, they're quite massive. So in novel approaches to topology optimization, you could, for instance, specify members, right? Is that, for instance, the structure would branch out when a certain member size would exceed or sort of converge, conversely. Also, in terms of resolution, in a sense, the topology optimization was quite low res, I would say, right? Now, in a sense, topology optimization is taking place at the gigavoxel level, right? So since it's so determining sort of and informing the structure of the building, it would be interesting to see what advances in topology optimization would inform this this agenda. And what I mean by topology and topology, it seems that, you know, some of the plans of the buildings presented are just spectacular, right? But I think they're very much informed by the structural optimization, right? So I'm also curious what would happen if you take more into considerations aspects of circulations, where sort of the typologies, top-down design typologies would invoke questions of topology optimization. You see, this is very much architecture designed from the outside towards the interior, where it would be interesting to sort of, you know, think of conditions that would be typological conditions that would inform your topology optimization. So that's my 2 cents.
And I add to these comments, I very much agree with you, Jelle, that sometimes I also miss the inside pressures on the outside a bit. So I totally align with that. But I wanted to also give a last. So many good things have been said about your project already, and I am so impressed by the work. So it's really amazing, amazing, amazing. So worked out. I want to make a special mention about the ground again, because I have mentioned this in relation to other projects of the studio. In your case, I very, very much appreciate that your first intention and your first move was to do something with the ground in relation to the city. So like facilitating that the water can get to the river. And that is something that, let's say, the big gesture is an infrastructural one. That for me is very valuable. I also very much appreciate the fact that you're working on both sides of the river, and that the creation of this, let's say, system that then becomes the kind of bridging to the other side. I find that very, very, very nice. And well, this the connection to the existing neighborhood, I also think that is very, let's say, finely created, if I may say, and maybe also to mention that I find very interesting how you locate different activities on these pebbles, and maybe just to also give a little bit of a critical aspect to it, is that the roofs of these pebbles are so large, and all tend to be almost like umbrella type. And what happens is also that in a heavy rain situation, you basically are dropping the water on the ground, when in fact you could potentially use the same pebbles to contain it for a while and to retain water, so that not only the ground would facilitate, let's say, the hydrology of the ground would facilitate that the water gets to the river, but that maybe the roofs of these pebbles could facilitate the containment of the water for some time before you actually leave it onto the river, so that the water management aspect could be very, very much contribute. The architecture and the water management could go much more side by side. I think very much contributing to the architectural expression of this all. And I just want to say it's a wonderful project. If it wasn't, and that is only something that you could, even like the wind, that you're looking at the performance, then also to investigate the water management on the ground. That's all.
Yeah.
Yeah, I mean, I think a lot has been said about the project, and I kind of want to recognize, I think, the commitment of actually kind of working through, I think, a very ambitious brief, but I think it's important to just situate, and I think this project maybe is a good example of it, but from what we've seen over the last couple of days, if you allow me in this kind of closing moments, just to kind of recognize, I think, all the efforts that the students have made. With respect to the project and with respect to the teaching staff, I mean, there was a moment, obviously, that we had to pivot and actually radically change, in some instances, a lot of the ways that we've been working on it. And the reason I mentioned that is, of course, that comes with friction, that comes with, you know, unsaid efforts to communicate, especially as we're kind of dispersed all over the world. And I just think like the last 2 days, honestly, kind of to echo a little bit to what Wolf said, has been amazingly important. I think not only personally from my side to see a lot of that effort that everybody's been making manifest, but I think the high level of conversation and the output, which honestly, I think is a testimony, I think, to a larger kind of belief system that this not only matters, but there's a commitment to design, there's a commitment to deal with different problems, but there's also a commitment to actually work on actually radically different briefs and have a way of kind of thinking about diversity and discussion of projects and agendas in a way that's mutually respectful and actually is really complementing each other. And I think that for sure, with particularities to the gamification, to the game design, to the ideas of visualization and all of these things that we've put a lot of effort into somehow enabling that communication, I think the results are very important as a testimony of a response to a moment where actually has been, I think, reaffirming, I think, a certain position in terms of the need to actually have more discussion, the need to actually bring communities together. I mean, it's amazing, I think, from my side to have people from Penn and SciArc, to have Wolf and Suhair from Google and all of that, and for people to accept the invitations to come and to engage this work. And I think in many ways, also in the context of the AA and the future of where things are going, I think it's even more important to show that, you know, students are really proactive and can be very creative, not only in terms of the design proposals that they're doing, but in the ways that they're choosing to work on things in a year that is really unorthodox. And I just think like this project, from the visualization to everything, to things being dropped these last sessions over the last couple of days, I think for me is quite inspiring. And I say that because obviously this has been probably one of the more difficult years from that perspective. And having a group of people of 100 that have to work together and collaborate, I do think it's important to state. So from the student side, I really think that you rose to the occasion and are showing a better way forward to how to do these things. And comments like when Rob and Ali and Hinar are talking about practices and how things are actually really emerging, you're showing, I think, the possibility of actually thinking about things and doing things in a really proactive way. And I only say that because I think the conversations, it's almost difficult for me to relate to the fact that we're in a pandemic and having really difficult conversations from the scale of the hospital to the scale of a city, and that you guys are enabling that and enabling that in a way that is coherent, even if the scales and the demands and the types of projects are different. I only wanted to sort of close the day with that because I think it's super important, and to open it up for closing comments from all of our critics, which I'm going to say again, I feel a deep sympathetic, empathetic relationship, even slightly nostalgic, since I got my phone flooded with messages because we returned to broadcasting this again, which means that it allows a lot of people to be able to participate and to feel that these conversations are not internal, but they are shared. So I think that yeah, I'm quite proud of the students and the staff for responding in the way that they have. And again, very thankful for the critics to engage in those discussions. Outside of that, I don't have very much to say, but I think you guys have 2 weeks to continue to think about things, and I think it's really meaningful to think about what the future steps are, because very quickly so-called reality enters in, and this new normal, to be honest with you, is not being contested with a kind of passionate and obsessive manner that actually is going to be more than just a career or a job. And the same thing, I think, when Wolf is mentioning about schools, this is the place where you're experimenting. This is the place to test ideas, but this isn't the graveyard where these ideas stay. And I think it's really important to keep that kind of spirited thing moving forward. So I just wanted to do that because in some sense, I think it's really great to have everybody together. But actually tomorrow's a new day. And the question is, obviously, after you wake up from your hibernation, I think the questions about how you're going to continue is really important. And we've tried to bring people together that are actually struggling with those things too. What practice is, what it means to educate, why we do these things. And I think that came across in a lot of the comments, obviously, in terms of sharing those experiences, but then also you guys being able to have a very high level conversation, which I think we've all craved for some time. So I just wanted to thank everybody for that. I think this has been a really good couple of days to kind of reinvigorate a little bit all of the trials that we've gone through in different forms.
Hey guys, it's really great. I'm just going to start because I need to take off, but it's really great to see the work. And I agree with Wolf, it's so optimistic. And in this time, it's fantastic, right? And you understand that everyone's working remotely, and these pressures in the external system are so great that, I mean, work coming out at this level and this level of thought is really great to be a part of, right? That's why we do this, quite honestly. In a funny way, the pandemic has allowed us to kind of reconnect in different ways, and I find that really amazing. I mean, everyone you invite is going to come, it's kind of, this is just one of those things that we're just trying to come together as a community. And you see that and you feel that, not only in the commentary and the optimism of the work, and these students are really going out of their way to push us to think about issues. So maybe it's the briefs, but it's also, I think, each student team promoting and provoking a set of issues that are challenging to think through, but also interesting to think through, right? So it's, we're not trying to, I think it should also be mentioned that the conversation has been great because it's been really about provoking ourselves into your work and understanding how that work could manifest into really altering culture, right? And I think that all three of these tracks that I've been witness to, I've really enjoyed. And I think that what's interesting about the briefs, I mean, it's clearly, right, they're very related kind of systemically to one another. I mean, I didn't only saw one of Shahjay's projects, but I can imagine everything is based in kind of game theory, et cetera, and gaming particularly, but yours, Theo, I mean, it's kind of fascinating to kind of step back into the DRL after many years. I mean, I don't remember the last time I was there, but the work is just, it's kind of interesting. The design research has just evolved and evolved and evolved, right? And then you see it here, then you see it here, but the strains are still there. It's not, it's been great for me to see kind of how you guys have evolved. And I've enjoyed participating and just seeing where you guys are at today. The one thing which I find fascinating about all the work is that it is taking on real world issues, right? It's not so consumed with itself. It's consumed with taking on ecological issues or taking on, you know, disaster scenarios or healthcare scenario, which is also a disaster scenario, or, you know, thinking about business models and how they might facilitate a new way of thinking about architecture and design. I think these are great strands, you know, to explore. And when I was thinking through the three kind of strands, I think I mean, I know it's not possible right now, but it could be very interesting to have some of these strands kind of, you know, shift from one to another. So, for example, it'd be great to see a business plan for this kind of project in London, right? One of Patrick's projects, and how that might mitigate thinking about square footage, as well as kind of all these systems and techniques, and how that would really infiltrate a way of thinking about making a city like this, right? Which I would find fascinating, in addition to the ecological and so, you know, et cetera. And then, you know, the sort of the terrain of some of these disaster relief projects coming back into Shajay's work and thinking about, you know, I mean, I just think that the cross-pollination has so much potential, right? And I know it's probably not possible right now, but I mean, when you guys gather and have these reviews, I think the students should be open to listening to the other sections, because there's so much you can gain in your own work, right? But again, that's for a later day. But I was just kind of fantasizing for myself. The potential of this kind of cross-collaboration might breed something kind of fascinating.
Yeah, and I've been thinking about that for a number of years.
It's great though, really. Thanks a lot for the invite, guys. I really enjoyed it. It's great seeing old friends, and
I think it would be a complex, but probably rewarding.
Yeah, yeah.
And worth trying. I think it's worth trying also because certainly being here today, I forgot about the pandemic while I'm listening to the projects and getting into these, you know, all the issues that were brought up in each of these three studios. I mean, I forgot about what was going on, which means the work was very compelling and gripping. I agree with everything that has been said so far, and how amazing that all of you have worked so hard in groups that are probably scattered everywhere, but yet to produce coherent projects at the end. You've learned a lot of skills, you know, unrelated to the studio, but will, you know, keep you going well in the future. I really like, Theo, how you organized the 2 days, that they're three very different projects, very different concerns, yet all very intelligent in their execution and rigorous in their execution, to be commended in how it's been structured and how it's been deployed. So both the faculty, the assistant, you know, all this long list that you have on every studio slide of everyone who was involved, everybody, you know, huge kudos to all of you. I really enjoyed the work, and look forward to, yes, finding some way between Zoom and being there that we can continue this optimistic collaboration.
Yeah, I would second all the comments that Hannah and Ali have made just now. I mean, for me, it's an absolute pleasure to see your work. I think all three studios are doing really ambitious things that are both creative and critical of where we are right now, and all the issues that we could be dealing with. I also think, having taught a studio in the DRL for a long time, it's a real pleasure to see that you continue to grow and push new boundaries and not stay comfortable. I don't think DRLs ever stay comfortable, but it's really nice to see that you're really taking on issues head on and really trying to work through these creatively and critically. I also think there's a little bit of the spirit, having got some distance now from the AA over the last 4 years. It's nice to see, I think, the spirit of the AA really much in the DRL, where architecture is a bigger problem than just one answer or just one method, and that every project is embracing as many kind of ingredients as possible in both what is the role of the architect, but also what are the means the architect has to really make a difference in the built environment. So, you know, and I think the three studios take these things on in very different ways, and they're very complementary. So I quite like Ali's suggestion that you try to find some cross-pollination. I don't know whether it's one studio trying to take on the other thing, or even having like maybe some point where there's kind of a inter-studio collaboration, you know, like that could be interesting to do, even if it's, whether it's in the year or if it's in a kind of 3 month period after the program finishes, where you literally pair these people together. That could be an interesting thing. But congratulations to the students and to Theo, Patrick, Shajay, and Alicia for some really great projects and great discussions today and yesterday. It's been a pleasure.
I'm just going to cut out and say bye-bye. I have to go. Thank you very much, guys. That was really amazing.
Thanks, Ari. Good to see you guys.
Same here. Thank you. Bye-bye.
Bye.
See you later.
Bye-bye.
Bye.
Thanks for a wonderful day.
Yeah, thanks for the invite. It was really, really stimulating to see. Thanks, you guys.
Congratulations to all the students.
Thanks.
Thanks, guys.
Thank you, everyone.
It's bedtime or movie time or whatever, or drinks.